Here's a map of ancient Egypt. I've inserted two sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows of different lengths. For the observed difference in these shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment.
All right, well, I hope you enjoyed that introduction by our friend Carl Sagan there. Today we're talking about a very important topic, which of course is Eratosthenes. If you don't know who that is, then today will be very educating for you. If you do know who that is, then today will also be very educating for you, hopefully, if you keep an open mind. Today we're continuing our cosmology series, of course, with episode number 4 in the series titled The Fatal Error of Eratosthenes. And of course, Eratosthenes is very popular in the heliocentric discussion. A lot of people like Carl Sagan, Neil deGrasse Tyson, all of these front men of the heliocentric model are always referring to the brilliant genius of Eratosthenes, how he calculated the circumference of the Earth and the spherical curvature of the Earth just using a couple of shadows and some simple math. So it's a very big achievement that this man supposedly achieved. But unfortunately, he was wrong. And not unfortunately for you, because you know the truth, but unfortunately for the people trying to defend heliocentrism with Eratosthenes' experiment, unfortunately for them, because he was very wrong. He had a fatal error in his experiment. And of course, modern science has never questioned it because they know the error. And so they use illusion and deception and clever stories and charming, people to basically tell you one thing that actually isn't the truth, to tell you a misrepresentation of reality, and to use a flawed experiment as evidence, when in fact it's actually evidence against them. So that's what we're going to be looking at today. I showed you Carl Sagan in the beginning because these people are professional storytellers, folks. People like Carl Sagan, Neil deGrasse Tyson, they're all secret society members, occultists, paid actors, operatives of some kind. You can do a little digging on your own and come to whatever conclusion you'd like on that. As far as I'm concerned, these people are paid actors. They're there to help weave the story. Science is not science anymore. I hope that you've realized that since 2020, when a different branch of science, health, became completely obvious. It became completely obvious how corrupt health is. And of course, if you've studied health, like if you know about the Flexner Report in the early 1900s and how basically that put an end to modern health science by way of J.P. Morgan Chase and Rockefeller, who had recently discovered that you can make drugs from petrochemicals, oil. So he wanted to corner the market on health. And so they hired a man named Flexner who went around to every naturopathic college and homeopathic school and everything like that, wrote a report basically discrediting all of these institutions. They lobbied for Congress, and pretty much the pharmaceutical industry was born 20 years ago. Before that, I mean, people were doing all kinds of different modalities for health and healing. And of course, that is a free market situation. So there are going to be snake oil salesmen, but at the end of the day, the market corrects itself. But if you want to capitalize on the market, then you have to discredit everybody else. And that's exactly what happened with health. And again, if you've studied health history, like for example, even the Keys study, the Ansel Keys study with cholesterol, and how it was completely fabricated for like literally 30 years, nobody talked about it. Where this man fabricated his results. He was the chief of the, what do you call it? Was it the FDA? One of these, like American Heart Association, I think it was. Ansel Keys, like in the 70s or something. Anyway, he fabricated this study, famous study, which is, of course, it's a famous fraud, but it's a famous study that for 30 years, just about, we were making recommendations on reducing cholesterol, and pretty soon we've realized that cholesterol is not the problem. People in the 1800s had an average cholesterol of like 220 or 250. So what's the problem? Well, the problem is inflammation. That's the problem. The problem is inflammation and other problems like high blood pressure, which is caused also by inflammation in the artery walls. And so that creates these striations in the artery walls. And then cholesterol your body uses to repair, and it starts to send cholesterol to these wounds, these little micro tears in your arteries, and that's how you get buildup. Of course, there's other aspects too. If you have a calcium mismanagement and you don't have enough vitamin D and vitamin K and magnesium and boron in your diet, which is hard to do, that's why you take supplements. All of these things together, I talk about quite a bit of these in my book and my health blogs, and so health has been a very big part of my research. I don't do so much of it now, but it's there. And my point for all of that is that if you've done your research, you know that health as a science, with all the jib jabs and all the things that you've been told that you need to be doing this to be healthy, is a scam. So do you think that other branches of science are immune from corruption? From the corruptive influence of the people at the top? Of course not. And so that's been the case, especially in the last 100 years. And physics is no different. So all of these people like Carl Sagan, Neil deGrasse Tyson, all these front men that are very charming, they're very good storytellers. Oh my gosh, that Carl Sagan video, that's why I put it up there. It's such a charming story. It's got this guy, Eratosthenes, and he figured this out, and look at this cute little drawing, this graph, and he's bending it for you. Oh, that's how it works. That's how it works, man. Of course, that's not how it works at all, but the math does work. And that's the thing I want you to learn today. That's one of the things, but one of a very important goal of today is to realize that math working doesn't mean that something is true. If you can make that distinction in your mind, you will progress very far in this particular topic, in this particular discussion. Because a lot of people think, well, the math works out, so it must be true. No, not at all. Math is just about relationships. And we're going to reiterate that point over and over as we do this, because my goal is to break you free from these charmers, from their spells. They cast their spells because you don't question your assumptions. They show you a little cute thing, and then, they give you this explanation, this story about how it all happened, and you just get wrapped up into the spell, when in reality, it is horrible science that Eratosthenes did. Now, in some sense, maybe we can't blame him, because you'll see why. There are certain things that they just didn't realize, like refraction and the behavior of light waves at that time. Maybe they did, who knows? But either way, it was bad science, and good science is always questioning. Yet today you are told by the science priests, whether it's in cosmology or in health or anywhere else, the science is settled. Don't question it. The science is settled. How dare you question science? When in fact the most scientific thing you can possibly do is question the science. There's nothing stupid or ignorant or whatever other derogatory word people like to use for people like me and maybe like you who question cosmology. There's nothing wrong with that. That's one of the most scientific things you can do. What is the nature of my reality? Okay, well, this person says he supposedly measured the curvature of the Earth. How did he do it? What factors did he ignore? Are there any variables that he ignored that could call into question the entire experiment? And of course, we're going to be answering that today. Heliocentrism is wrong, but of course, if we can debunk Eratosthenes, then the whole ball model falls flat on its head. See what we did there? With that, make sure you hit that subscribe button, share. I hope this will edify whoever is watching it. Every like rescues a Fennec fox from spinning at 66,600 miles an hour. So we want to make sure that we rescue a few Fennec foxes. Today, you're going to learn how science and math can be manipulated for an agenda. Hopefully, you've already learned that by now. But if you haven't, then today will be a nice review. Because ultimately, again, if something is mathematical, it just means it's mathematical. It doesn't mean it's true. Very, very important. Also, just another quick note, I'm still working on audio issues. This video, by the time this will be published, I'll probably have my computer back. At the time of this video, I'm having to send my computer in for repair. Not related to the audio issues. It's some stupid hard drive thing. I swear, I've had nothing but problems with this machine. I've spent like a ton of money on it. And my last computer was very crummy, but I didn't have any problems. For like 10 years, I had no issues, ever. Now I get a very expensive machine to be able to render all these long videos and do the work. And it's just been nothing but problems, man. So I would appreciate your prayers that everything goes right with my technology, because that seems to be an area where I get attacked quite a bit. But at the time of this video, I need to still send the laptop. So probably this video is not going to be out until a couple more weeks from now. So when you see it, my audio issues I'm going to see today if my audio issues are still going on, because I'm trying a different browser. Last time, on Wednesday, I tried to see if I could do various settings and so on. This time, that still created errors. I can't figure out what the issue is. I really can't. So if you know anybody, or if you yourself are a nerdy person when it comes to audio and computer stuff, then please email me, tutor@danceoflife.com. But today I'm trying a different browser. We're going to try the Brave browser and see if that works any shenanigans with these video sites like YouTube. So we'll find out. And if that doesn't work, then I'm going to try downloading the videos, because every time I comment on a video, there's something that happens where it interrupts my signal for like half a second. And it's strange because it happens predictably. It happens predictably and unpredictably. Like there's a pattern where it interrupts 10 seconds after I hit the stop button on the video. 10 seconds. Then it interrupts my signal, which is very strange. And then it happens randomly too. So it's just like, what the heck's going on, man? I'm just so annoyed. Anyway, I apologize for these interruptions. It's really frustrating. So thank you for your patience as I work all of this out. But moving on to the first section. Who is Eratosthenes? Who is this guy? Let's read about him. Hopefully you already know who it is, but if you don't, that's okay. We're going to find out today. Eratosthenes on Wikipedia. Yes, you can see it. Good. Eratosthenes of Cyrene was an ancient Greek polymath, mathematician, geographer, poet, astronomer, and music theorist. He was a man of learning, becoming the chief librarian of the Library of Alexandria. Remember that one, that's important, because that was the seat of the occult until Alexandria burned down. His work is comparable to what is now known as the study of geography, and he introduced some of the terminology still used today. He's best known for being the first person known to calculate the circumference of the Earth, which he did by using extensive survey results he could access in his role at the library. Really, he just used a couple of sticks, and he hired a guy to find the distance between two places, and he calculated the elevation angle. But anyway, notice the story already building. His calculation was remarkably accurate. He was also the first to calculate Earth's axial tilt, which is also proved to have remarkable accuracy. Do you feel that you're tilting? He created the first global projection of the world, incorporating parallels and meridians based on the available geographic knowledge of his era. So he's just this amazing man that was such a brilliant genius, and he did all these things for advancing cosmological science, according to the mainstream narrative. If we go down to life, we read about him there. Let's see. Eratosthenes went to Athens to further his studies. There he was taught Stoicism by its founder Zeno of Citium in philosophical lectures on living a virtuous life. He then studied under Aristo of Chios, who led a more cynical school of philosophy. He also studied under the head of the Platonic Academy, who was Arcelianus of Pitane. His interest in Plato led him to write his first work at a scholarly level, Platonikos, inquiring into the mathematical foundation of Plato's philosophies. This is very, very important, my friends. You will see why this is very important, that this influence exists. And of course, Plato isn't the only influence. Pythagoras is also important. We'll get to that. But Eratosthenes, basically lived around the Hellenized period around 200 BC, approximately. And he did all these things for heliocentrism, supposedly, and he was also very influenced by Plato. And of course, Plato is a very influential figure in many different kind of ways. So, here we go. This is measuring the circumference of the Earth. This is by Khan Academy. And it gives us an idea from the heliocentric perspective what the amazing feats of Eratosthenes was. This is by Cynthia Stokes Brown. More than 2,000 years ago, Eratosthenes compared the position of the sun's rays in two locations to calculate the spherical size of the Earth with a reasonable accuracy. Studying the Earth. Eratosthenes may have been the first to use the word geography. He invented a system of longitude and latitude and made a map of the known world. He also designated a system for finding prime numbers, whole numbers that can only be divided by themselves or by the number 1. This method, still in use today, is called the sieve of Eratosthenes. Eratosthenes was also the first to calculate the tilt of the Earth's axis, which he figured with remarkable accuracy. The finding was reported by Ptolemy in around the 2nd century BC. Eratosthenes also calculated the distance from the Earth to the Moon and to the Sun, but with less accuracy. Well, then he didn't calculate it now, did he? He made a catalog of 675 stars. He made a calendar with leap years and laid the foundation of chronology in the Western world by organizing the dates of literary and political events from the Siege of Troy, which was about 1194 BC, to his own time. Yet his most lasting achievement was his remarkably accurate calculation of the Earth's circumference, the distance around a circle or a sphere. He computed this by using simple geometry and trigonometry and by recognizing Earth as a sphere in space. Most Greek scholars by the time of Aristotle agreed that the Earth was a sphere, but none knew how big it was. This is important to understand that by the time Aristotle was around, which was before Eratosthenes, the Greeks had been swayed by the occult obsession with spheres, and we'll talk about this in a second. How did Greek scholars know the Earth was a sphere? Well, they observed that the ships disappeared over the horizon while their masts were still visible. Now, this is a lie because ultimately, we looked at proof of these in the first episode of this series, where you have ultra-high magnification capabilities, you can bring ships back from the horizon. And in fact, a lot of times, they're under the horizon. So what does that tell you? It tells you that they're on a flat plane. And what happens is that as you zoom out, you have less and less light information that is able to be distinguished by your eye. There's a resolving power that your eye has, and there's a threshold, what's it called, like the Rayleigh factor or something, where basically the wavelengths of the two things that you're seeing are blurring into one, and so the effect is that they disappear, that the ships disappear. But they're not disappearing over the curve, folks. They're disappearing because there's not enough light energy hitting your eyes. Everything else is interfering. It's an interference pattern that causes it to disappear, which is proof because we can bring it back into focus with high magnification. Anyway, moving on, they saw that the curved shadow of the Earth on the moon during lunar eclipses. That's also a conjecture. That's not the curved shadow of the Earth. Because in fact, I have a whole thing we'll be looking at, but this artist made this video. It's a great video on perspective, and basically, it's an artist. He's an artist, longtime artist, and basically said it's impossible for the moon to be a sphere because, this is very important. I wish I had the video queued up with me. I just remembered it now. But anyway, we'll look at it in a future episode. When you have a sphere and you cast a shadow on it, if the Earth was casting its shadow on the moon, and that's what causes the phases of the moon, which is nonsense, then you should see the shadow having a particular pattern that it covers the moon. In other words, the way that it looks like is actually that there's a two-dimensional surface, and there's just almost like a shadowy filter that comes over it. That's what it looks like. It doesn't look like a ball and a shadow is being cast on it because the sphere warps the shadow's shape. It's hard to explain without showing a visual. Hopefully maybe in your mind's eye you can see what I'm talking about. And plus we looked at photos. I took pictures. You can do this yourself. Watch the sky and look at the moon in the sky. The moon in the plain daylight. I showed you several pictures that I took of the moon and the sun in the plain daylight, showing you that it's impossible for the shadow of the Earth to cast the phases of the moon. They're not related. The phases of the moon is its own phenomenon, and of course we can speculate on what that is, but it's impossible for the sun and the moon to be in the sky at the same time, and every day the moon is a different amount of phase, right? It gets thicker and thicker or wider and wider or whatever, which doesn't make sense. If the Earth and the sun are working together to create light effects on the moon, how can the moon be in the sky relatively the same position day by day, and yet the phases of the moon are changing? It doesn't make any sense. We looked at that. So that's not why they thought the Earth was a sphere. They thought the Earth was a sphere because they were obsessed with spheres, and you will see that wasn't always the case. That was an occult situation that started probably with Pythagoras. But anyway, and they noticed the changing positions of the stars in the sky. Does that mean that the Earth is a ball flying through space? No. Means that the heavens are moving. Why is that not a possible consideration? Of course, that's what most cultures believed, and we looked at that last time. Measuring the Earth. Eratosthenes heard about a famous well in the Egyptian city of Syene, now known as Aswan, on the Nile River. At noon, one day each year, the summer solstice, between June 20th and June 22nd, the sun's rays shone straight down into the deep pit. They illuminated only the water at the bottom, not the sides of the well as on other days, proving that the sun was directly overhead. Syene was located very close to what we call the Tropic of Cancer, 23.5 degrees north, the northernmost latitude at which the sun is ever directly overhead at noon. Eratosthenes erected a pole in Alexandria, and on the summer solstice he observed that it cast a shadow, proving that the sun was not directly overhead, but slightly south. Recognizing the curvature of the Earth and knowing the distance between the two cities enabled Eratosthenes to calculate the planet's circumference. Now, he assumed that the Earth was curved, and you'll see why. Eratosthenes could measure the angle of the sun's rays off the vertical by dividing the length of the leg opposite to the angle. If this doesn't make sense to you, we'll have plenty of videos watching today that will illustrate this experiment. The length of the shadow by the leg adjacent to the angle, the height of the pole. So he's basically measuring. You can triangulate. What does triangulate mean? To triangulate something, right? To make it a triangle, to calculate a triangle. So you can, if you have a pole and it's casting a shadow, that the shadow is the base of the triangle. You have the height of the pole, and then you have an angle that points to the source of the light. That's a very simple way to calculate the trajectory of a particular light. However, it's a little more complicated than that with the sun, and you'll learn why. Hopefully you'll learn why, because it's so important. Eratosthenes could measure the angle of the sun's rays off. Okay, we didn't read that. Did we read that? Yeah, we did. This gave him an angle of 7.12 degrees. He knew that the circumference of the Earth constituted a circle of 360 degrees. Do you see how assumptive this language is? He knew that the Earth had to be a circle of 360 degrees. Like, how do you mean he knew that the Earth had to be a circle? He's projecting his understandings and his observations onto a model and calculating accordingly. That's not what you should do in science. In science, you have to try to refute your hypothesis. And if you can't, then you go to the next step. Anyway, just notice how unscientific the writing here is. But either way, so 7.12 or 7.2 to divide 360 evenly by 50 degrees could be about 1/50th of the circumference. He also knew the approximate distance between Alexandria and Syene, so he could set up this equation. He set up the equation, the relationship. You'll see a little graph here in a second. Eratosthenes estimated the distance from Alexandria to Syene as 5,000 stadia or 500 miles. He made this estimation from the time it took walkers who were trained to measure distances by taking regular strides to trek between the cities. By solving the equation, he calculated a circumference of 250 stadia or 25,000 miles in circumference. So basically what did he do? Here's Syene, the sun. Now, this is a model. This is not the truth, but this is what he calculated. He figured, well, here's Syene, and the sun is right overhead. And where I'm at in Alexandria, there's a shadow being cast. So this has got to be something going on here because there's a difference, right? And of course, you can explain that. You'll see it. We'll have plenty of videos to watch. You can explain this either with a flat plane and a local sun source, or a giant ball and an even gianter ball with parallel light rays, which of course is impossible. But either way, the math works out. This is the problem that you need to realize today. But either way, assuming it's a ball, then he figured, okay, well, the distance between these two places, what's the distance? It's about this much. Therefore, one slice of this pie, right, must be X amount of distance. Therefore, he multiplied that by, 360 degrees, and you get what? You get the circumference of the Earth, supposedly. So that's how he calculated it, based off of an assumption that the Earth must be a sphere, and therefore the distance between these 2 points is a particular slice of this pie that is 360 degrees. Several sources of error crept into Eratosthenes' calculations and our interpretation of them. I wonder if they're going to talk about the real source of error. Let's see. For one thing, he was using as his unit of measure the Greek unit stadion, or the length of an athletic stadium. But not all stadiums were built to the same length. In Greece, a stadion equaled roughly 185 meters, while in Egypt, the stadion was about 157 meters. We don't know which unit Eratosthenes used. If he used the Greek measure, his calculation would have been off by about 16%. If he used the Egyptian one, his error would have been less than 2% off the actual Earth's circumference of 24,860 miles. A century after Eratosthenes, the Greek astronomer Posidonius of Rhodes calculated the Earth's circumference. Again, Posidonius used the star Canopus as frame of reference. When the star is visible at the horizon in Rhodes, it is 7.5 degrees above the horizon in Alexandria. His first calculations came out almost exactly correct, but he revised the distance between Rhodes and Alexandria, which resulted in a number comparable to 18,000 miles, which is about 29,000 kilometers, some 28% smaller than the actual circumference. How do you know that the Earth is the one moving versus what if the heavens are moving? How do you know? That's a good question, isn't it? Ptolemy reported the calculations of Posidonius instead of those of Eratosthenes, and it was Ptolemy's writings that found their way to Christopher Columbus. Well, there you go. One hand to another throughout the heliocentric history. If Ptolemy had used Eratosthenes' larger, more accurate figure of the Earth's circumference, Columbus might never have sailed west. Gosh, I love the story. It's just so fascinating. Eratosthenes lived to be about 82 years old when he starved himself to death because he feared the onset of blindness. So, pagan rituals, pagan beliefs, and this is the person that we have based an entire scientific quote-unquote theory on. But of course it's wrong, and today you'll realize why it's wrong. This is a video from another sorcerer, Neil deGrasse Tyson. Let's see what he says. I think this has some good visuals in it.
So how do we know the Earth is not flat?
We don't. It's flat. So now if the Earth is round, how big is Earth? You might want to check for that. There was a famous experiment conducted by Eratosthenes. Eratosthenes. And the two cities in the old world, and one of them, they knew that at 12 noon on a particular day of the year, that the sun was directly overhead and you could see the bottom of a well.
Oh, okay.
You don't run around looking at the bottoms of wells.
No.
Because the light doesn't take, it's just, no.
Doesn't get down.
Do you notice the entertainment value to these things? This is just entertainment, folks. It's a clown show.
Doesn't get down there.
How can we use this observation to see if Earth's surface is curved? We needed another well. Turns out we can't see the bottom of both wells at the same time. What might explain this? Well, there are two possible explanations. First, we could have a flat Earth with the sun that's small and close by, so that the light hits the second well at an angle.
Do you understand? Two possible explanations.
Or second, we could have a curved Earth with a sun that's big and far away, so that all the light comes in parallel.
Light does not do that. It doesn't. This is a conjecture.
But only one well at a time is lit all the way to the bottom. Turns out with just two wells, there's enough wiggle room for both explanations to fit our observations.
The same phenomenon Eratosthenes measured could be explained by a flat Earth if the sun were only a few thousand miles away and 32 miles across. The math would work out the same.
I wonder why. Well, probably because math doesn't tell you whether something is true or not. It just tells you the relationship between two things. Now, the problem with this experiment and with reality, which we will learn today, is that we can't triangulate the position of the sun. Because with two wells, it could go either or. The problem is when you have a third reference point. The third reference point leads to a problem called the triangulation problem, meaning when you draw these lines, we'll watch other videos, you'll get a very good idea of it today. The problem is that they don't have the same result. So what they did to make the math work is curve the surface of the Earth, when in fact actually what's happening is there's a refractory type of lens, whether it's the atmosphere, the firmament, whatever you want to call it. I don't know. We don't know exactly what it is, but something is refracting the light of the sun. Therefore, you're going to get an irregular result when you get three or more reference points. This is the issue. With two, you could explain it either way. Do you get the point? That's the point of today. Of course, we have to look at the issue with three, and that's going to be coming up next. But what do we take from that? Well, Eratosthenes, if he was a real person, was very much influential in his day because of this experiment. And of course, he's very influential in the story of heliocentrism. A lot of people use this as their go-to to say, see, we've known the Earth has been a ball for 2,000 plus years. Heliocentrism has been around forever, and it was measured by the ancient Greeks. Not true. This is a false claim, and of course, it's false for several reasons, because most of the world believed that the Earth was an enclosed, flat cosmology. We looked at that last time. I gave you 18 examples, and there are even more than that. So do the math. If all those cultures were extremely advanced, astronomically, scientifically, they could predict the movement of the heavens, that tells you that there are more than one ways to explain something. The cosmology of the ancients is very different than modern day cosmology, and yet they were able to build enormous structures that were aligned with the heavens. They could predict celestial events. So obviously they weren't stupid, and obviously their model of the universe wasn't as primitive as people may think today. The Greeks were unique because they had all kinds of occult beliefs, and of course the mystery religion of the ages has infiltrated humanity since the beginning, but the Greeks believed in a stationary Earth, and we're going to document that today. However, philosophers like Pythagoras and Plato, and eventually obviously Eratosthenes and Ptolemy and everybody else, were very influential in hijacking that cosmology into a more occult, sphere-obsessed type of cosmology. Everything must be a sphere, including the Earth. The Greeks were obsessed with spheres because the sphere represented a philosophical concept of perfection. That's why all of these people, like Pythagoras, will look at, they thought the sphere represented the perfect thing. It was perfection, basically. And so, therefore, the Earth must be a sphere. If it was created, it must be a sphere. And this is just an assumption. It's an assumption from a religious belief system. It's not based on science. And you'll see in a future video, probably the next one after this one, where we look at the heliocentric conspiracy, that heliocentrism is impossible to be divorced from occult belief systems. It can't be divorced from occult and mystery religion and mysticism type of religion. It can't. Every major figure in heliocentrism was an occultist and involved with mysticism. Eratosthenes, again, if he existed, I don't know, who knows, some of these things you really question, like, did this really happen? But let's say it did happen. Eratosthenes was the chief of the library of Alexandria. Well, if you know what that place was, it was the center of the occult and mysticism. It got burned down, but it was the center of the occult until it got burned down. So he was the chief librarian. Do you think that he dabbled in mysticism and the occult? Of course he did. Of course, all these philosophers were associated to mysticism and all kinds of mystery religion things. So let's learn a little bit about Greek cosmology to understand the history and progression of these things. This is from Harvard website. It's a copy from a book called The Cosmological Ideas of the Greeks, I believe. It's by McPherson in the Journal of Popular Astronomy, volume 24, page 358. The cosmological ideas of the Greeks. To the ancient Greeks belongs the honor of separating for the first time cosmology and theology. Just as the genius of the Hebrew people was religious, that of the Hellenes was in the direction of philosophy and art. And just as the Hebrews developed the religious view of the world, it fell to the Greeks to develop the philosophic view, which is true. As Eucken remarks, philosophy, which in the case of the Greeks does not start from man and the problem of his happiness, but from the universe as a whole, aims to comprehend the world in a natural way by means of its own interconnections. It seeks for an immutable substance or for fixed quantitative relations. It is forced to discard the first impression of things and to destroy their visible image, but with a sure instinct for the essential, it reconstructs the world in outlines whose simplicity bears the marks of genius and excites our perpetual wonder. Greeks were all about philosophy, folks. But philosophy is just, the Bible says the wisdom of the world is foolishness to God. Nevertheless, Greek cosmological speculation had its origins in the mythological age, and was at first similar to the mythologies of Babylon and other ancient lands. Very important. I wish I could highlight it, but I can't on this particular page. In the poems of Homer and Hesiod, we meet with earlier Greek cosmological ideas, and in them, cosmology and theology are, as in the Babylonian world concept, inextricably connected. Both Homer and Hesiod, in their poems, give us an idea of the worldview of the primitive Greeks. Oh yeah, they were so primitive, I'm sure. In Homer, the earth is a flat circular disk, surrounded on all sides by the great river Okeanos. This mighty river commenced north of the pillars of Hercules, and wound its way north, east, south of the earth. The disk of the earth is supposed to be partly covered with the sea. Southwest of the river Okeanos is the land of the Cimmerians, and in some places Homer indicates that adjacent to the Cimmerian land is Erebus, or the land of the shades. In other passages, however, Homer places Hades beneath the surface of the earth. Above the earth is the region of the ether, and still higher is the vault of the heaven. Beneath this vault, the sun, moon, and stars perform their motions, rising out of Okeanos in the morning and returning thither at night. The Hesiodic conception is somewhat similar. Hesiod places Tartarus, the depth, as far below as the earth, as the height of the heavens is above. Thus, the whole universe is represented as a sphere. Now, I did not. I need to go get that little graphics. I'll be right back. And we're back. So here is this. I forgot to put this thing up here, but this is what we looked at in the last episode, Ancient Cosmologies. This is an artist's representation of the cosmology of people during Homer's time, what they believe. So the earth is a flat plane. You have Tartarus and Hades underneath the circle of the earth. You have the vault of heaven, and you have Olympus, which is the home of the gods. Obviously, they had different mythologies. You had the sun and the moon being these local light sources, and they seem to be traveling on a track, which is interesting. The pillars of heaven, the rivers of the ocean. So this is what people believed in around 800 and 900 BC. This changed. This changed with people like Pythagoras. If we go to now, this next one is from Math's History. This is an article on Pythagoras of Samos. So Pythagoras was around 570 BC to about 490 BC. So around this time, things started to change with Pythagoras. He was a Greek philosopher, many important developments in mathematics, astronomy, and the theory of music. The theorem known as the Pythagorean theorem was known to the Babylonians 1,000 years earlier, but he may have been the first to prove it. Very influential person in mathematics also, but as you will learn in the future episode, Pythagoras was also very much involved with the occult. He had his own little conclave of young boys and all kinds of other things going on that usually is typical of these types of things. So if we scroll down here, yada, 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 one of the main points is Heath gives a list of theorems attributed to Pythagoras, or rather more generally to the Pythagoreans. So let's see, what are the theorems? Well, one of them is, in astronomy, Pythagoras taught that the Earth was a sphere at the center of the universe. He also recognized that the orbit of the moon was inclined to the equator of the Earth, and he was one of the first to realize that Venus as an evening star was the same planet as Venus as a morning star. So astronomy changed with Pythagoras in terms of the Greek astronomy and cosmology, because Pythagoras taught that the Earth was a sphere. Whereas before that, with people like Homer and the Iliad and the people before that, they believed in a very different cosmology, a cosmology that was relatively similar to everybody else in history in ancient times. But philosophers, occultists, mysticists started coming and doing all these signs and wonders and basically proving, various mathematical things, which Pythagoras' theorem is true. It works in mathematics, but Pythagoras also had a lot of occult beliefs, which is very important to understand. So he made contributions while also bringing a lot of deceptions along the way. Very, very important to understand. This is another one from Library of Congress, Ancient Greek Astronomy and Cosmology. The sphere of the world. By the 5th century BC, it was widely accepted that the Earth is a sphere, i.e. widely accepted among the Greeks, not the world, because if this means the world, then that's a false statement. We looked at that last time. This is a critical point, as there is a widespread misconception that the ancient peoples thought the Earth was flat. Yeah, they did. They did. This is a false statement. What do you mean the widespread exception? We looked at 18 examples across the entire world that people believed that the Earth was flat in an enclosed cosmology. So that's a lie. Even the Greeks believed that. You saw it for yourself. This was simply not the case. In the 5th century BC, Empedocles and Anaxagoras offered arguments for the spherical nature of the Earth. During a lunar eclipse, when the Earth is between the sun and the moon, they identified the shadow of the Earth on the moon. Of course, again, this is all assumption. Did they really identify the shadow of the Earth on the moon? No, they said this is what it is, but you don't know if that's what it is. Do you notice the unscientific language of this that's so hungry to tell you a particular narrative? As the shadow moves across the moon, it is clearly round. No, it's not. Take a sphere. Take a sphere, like a white ball of some kind. Put a light source and take a covering of something to cast a shadow on it. Watch how the shadow happens on a spherical surface. It doesn't happen that way on the moon. It does not. I'm assuring you it doesn't. The shadow, as it creeps onto a spherical surface, it's very warped. It does not do what we see with the moon. Anyway, this would suggest that the Earth is a sphere, yada, yada. So what's the point? The point is that Pythagoras, and then you had people like Empedocles and Anaxagoras and all these other philosophers that basically continued to create this echo chamber that the Earth is a sphere. Among the Greeks, remember the Babylonians, the Hebrews, the other people that we looked at in the Middle East and around the world, the Mayans, the Incas, and so on, everybody had relatively similar cosmology. Nobody had any reason to believe that the Earth is flying around through space or that the Earth is curved. When you look at the horizon, at the sea, everything is as flat as a board. So that's something to keep in mind. But these things started to change with the Greeks. And of course, the Greeks were very influential in philosophy. If you read about Plato, if you type in Google, Greeks thought the spheres was perfect Plato, something like this. Little AI overview is nice because it condenses some things. Yes, Plato believed that the Earth was a sphere and that the sphere was the most perfect shape. Plato's reasoning was that the sphere was the most complete and self-similar shape. He also believed that the Earth was stationary and at the center of the universe. So he believed the Earth was stationary, which matches observation, but he believed it has to be a sphere because spheres are perfect, right? Plato's student Aristotle also supported the idea of a spherical Earth, moon, and planets. Aristotle believed the sphere was a perfect solid and that the Earth's pieces would press into a round form as they fell towards the center. The idea that the Earth is a sphere was widely accepted by the 5th century BC, Empedocles and Anaxagoras, yada yada, we read about that. Plato maintains the world is spherical. He justifies this by asserting that out of all of the shapes, the sphere is the most complete and most self-similar. So is this a scientific statement, folks? Is this scientific reasoning, or is it occult, mystical, emotional reasoning? Of course, it's the latter. Plato thought that, well, spheres are just so gorgeous and beautiful and perfect that the Earth must be a sphere. When that assumes many things that are not observable whatsoever, but you have to believe it. So from the very beginning, heliocentrism was not based on science, but rather occult mysticism and emotional understandings. It's self-made reasoning. It's not actual experimental data. So what do we take from this? Well, what we take is that during the days of Homer, around, again, 900 to 800 BC, around that time, the Greeks did not believe that the Earth was a ball. The Greeks believed in a traditional cosmology like the ancients, where you had an enclosed type of system with local light sources and a flat plane. They believed the Earth was a circle. There's a circle of the Earth type of situation. And that's it. Doesn't mean they believed in the Gleason map. They just believed in a flat, motionless plane with local light sources. By 550 BC, around that time, you had people like Pythagoras and his Pythagoreans who began to teach that the Earth is a sphere. Pythagoras was very into the occult. He was obsessed with spheres, and we're going to document this in the future. We're going to look at the history of heliocentrism, and you will see for yourself the involvement that Pythagoras had with the occult. He wasn't just this like mathematician sitting in his house all day doing math equations. These people were philosophers, and of course you know what philosophers were up to. They had their own ideas of things. They had certain things that they did with young boys, let's put it that way, and they did a lot of occult things. He had his own, I think, like cult of Apollo that he had. I mean, they were occultists, okay? Yes, they were mathematicians. They loved knowledge, but they were also very corrupted by knowledge, by secret knowledge, by Gnosticism. Nevertheless, Pythagoras was very influential. Then you had Plato, who, of course, was obsessed with spheres and more from the philosophical side, like, oh, the sphere is the perfect object. It was almost like kind of an idolatrous type of thing. The sphere is perfect, and so the Earth must be a sphere. And of course, Plato was instrumental in philosophy, in Gnosticism. We talked about it in my Afterlife series with the immortality of the soul. That comes from Plato. People still believe that. We still, in Christianity today, people don't realize that their views on the afterlife are Greek. They're Platonic. They're Neoplatonic and Platonic, and there's nothing new under the sun, folks. That's the oldest time, 2,500 years old, almost, that people have believed such things because of Plato, and people still fight it today. The Bible doesn't teach of an immortal soul that separates after death and floats around or goes to heaven or goes to hell or whatever else. You are a living soul, and when you die, that's it. The next thing you're aware of is the resurrection. Everybody gets resurrected, and the righteous will inherit eternal life, and the wicked will be destroyed. Very simple, very straightforward. But this is history. You have to know your history. Of course, then we get to Eratosthenes a couple centuries later, around the 200s BC, who did his famous experiment and who was very influenced by these traditions of men and secret knowledge and occultism. So, is it true that the Greeks, quote, always knew that the Earth was round and a ball? Absolutely not. It's not true. You see it for yourself. Document it. The original Greeks believed that the Earth was a flat, motionless plane like everybody else. Of course, everybody, again, had different mythologies about, the world and where the underworld was, or, various things like where the gods were and things like that. But it doesn't really matter. Everybody had a general understanding that the Earth is a plane with an enclosure, with God or the deities above, with local light sources, and the plane is motionless. It doesn't move. You're not on a ball. You're not flying through space. And you're not in some vacuum or whatever. It's nonsense. Nobody ever believed that. And again, these people were very advanced. The Egyptians, the Incas, the Mayans, the Indians, the Japanese, all these people were very, very advanced people. And they could make very advanced predictions. So Satan began working and changing cosmology a long time ago. We're going to be really doing a very deep dive on this particular topic next time with the heliocentric conspiracy. But the Greeks were one of the first groups where Satan was working this new cosmological thread. And you will see when we get to that episode next time, all these heliocentric threads were started in different places at different times. And of course, all these were united through the Catholic Church, who Satan gave his throne and authority and great power to. The last 500 years of astronomy have been Catholic, folks, and I hope you realize that. The moon has 33 craters named after Jesuits. That should tell you everything. And of course, a Jesuit created the Big Bang. So look, your cosmology, when we're talking heliocentrism, is Catholic. And if you think that you can trust the Catholic Church, well then, I have some beachfront property to sell you here in Phoenix, Arizona. So the Greeks didn't always believed the earth was spherical. It was a development in Greek history because of the occult and mystery religion. So the people who changed that view, like Pythagoras and Plato, were very much into the occult and Gnosticism. There's also many assumptions in what Eratosthenes did that were never cross-referenced and checked or questioned. And we're going to question them today because they're going to be refuted. Today we'll watch several important clips from various videos that will discuss this experiment and falsify it. And you'll see it for yourself. My goal is to prove to you that math can be used to deceive, just like the Bible. The Bible is the Word of God, folks, but look at how many people are using the Bible, unfortunately, to deceive people, like the prosperity gospel or whatever else, the charismatic movement, or even the Catholics or the Orthodox that use the Bible to support their legalism. The devil used Scripture to tempt Christ. That should tell you everything. The Bible is the sword of God. It's a weapon in that sense, but you can misuse that weapon. So the same thing is with math. Math is a source of objective measurement because it's relationships. 1 equals 1, 1 equals 2, 2 plus 2 equals 4. So the equations have to balance, right? There's an objective reality we're dealing with. But just because something is mathematized doesn't mean that it's true. It really doesn't. And I hope you realize that because this is how they cast their spell. They use math and conjecture and illusions and clever presentations and stories and assumptive language, like how we read on these various places, like from the Library of Congress. Oh, well, they saw that the Earth's shadow was covering the moon. Whoa, wait a minute. When you read a statement like that, they saw that the Earth's shadow was covering the moon, so they knew that the moon must be a sphere, or the Earth is a sphere, whatever. If you accept that statement without questioning, like, wait a minute, what do you mean they saw the Earth's shadow on the moon? How do you know it's the Earth's shadow? That's the question you should ask. How do you know it's the Earth's shadow? But if you accept that statement, they're speaking presumptively with you. Do you understand how this works? This is how they cast their spell. So my goal is to really help you grow some Fennec fox ears today because you need to be very, very sensitive for this particular topic. And it's simple. The experiment Eratosthenes did is very easy to refute. But we have to go through some of these videos. I have about, 3 different videos we're going to go through. And we're going to go through some other important proofs too, so you understand how you can use math against them. But either way, the point is we have to go through these videos so you see for yourself the experiment, the issues. You see visually what's going on. Some of this stuff might be maybe a little heady. Don't worry about it. We're going to summarize it. But I want to document it here so that anybody in the future can always come and look at these various videos. And of course, you can go and look them up yourself as well. The first video is from, actually, most of these are from a guy named Decimal Z on YouTube, who, as far as I'm concerned, has documented a lot of great experiments. There's a lot of people that say, oh, look at NASA or look at this. Like, okay, great. Everybody is doing that now. There's not too many people doing experiments. And so Decimal Z has some great videos on YouTube. He's the one that did the 40-kilometer laser experiment over the lake that I've cited previously, I think in the first episode of this, where we looked at different proofs for the horizon. 40 kilometers laser experiment. He's got a whole video on it. Go check it out. You can find the data yourself and see for yourself that there's no such thing as curvature. He's got a lot of good stuff. Highly recommend him. He does believe the Earth is a circle, and I've emailed him about this. We exchanged some emails back and forth. The last one I sent him, he never replied, so I don't know if he's just busy or maybe he just doesn't want to talk anymore about it. I was challenging him on the fact that the Earth is a circle. The Earth can't be a circle, and we will look at that in a future video in this series. The Earth cannot be a circle, but if that's the case, then what do you have? Well, I don't know what you have. You have a supernatural situation, because I know that the Earth isn't a ball, I can tell you that. But if it's not a circle, then how do you explain continuity? Of course, we're going to explore that. But he's from an engineering background, if I'm correct on that. I believe he was either an engineer or he was doing some sort of engineering background. And he uses AutoCAD. If you know what AutoCAD is, it's a very precise software that you can recreate certain things and relationships and put them in a virtual space. And then you can also build experiments off of that too. So if you know what that is, if you don't, that's okay. You'll get a taste of it today. But this first video is titled How They Fooled the World with Deceptive Calculations. So we're going to start around, let's see, 4:30, and we're going to go for about 20 minutes or so. And here we go. Let's see. Hopefully no sound shenanigans. Play.
In the time of Eratosthenes. At that time, you would probably believe that the Earth is flat, because it is exactly what you observe. The first thing you might want to do to understand the universe is to measure the distances between us and the sun, moon, and stars. To do this, you will have to triangulate them. So obviously you're gonna start with the sun. So you're gonna need at least 2 sticks. You're gonna place them on the ground as far as possible from each other because the sun is obviously big. Then you measure the shadow of the 2 sticks at the same time to get the elevation angles of the sun, and then you measure the distance between them. So for example, if the distance between these 2 points is...
So do you see how this works really quick so you understand the whole shadow idea? Here's a stick, okay, and you have a light source, in theory. With the actual sun, you're going to see what the problem is, but let's presume that this is just a normal light. You can do this on a table with some matchsticks or some dominoes yourself. The light casts a shadow for these sticks, and then you can go to the end of the shadow and draw an angle of, see, okay, what's the angle of basically this line, and you can calculate the distance based on simple math, because you know the distance between these 2 rods, so you know the base of the triangle, you know the angle, you know the height, and so on, and so you can calculate very simply with just some simple math. So moving on.
It's 2,074 miles, and their elevation angles are both 75 degrees. Then the distance to the sun will be 3,870 miles. Here is the math behind it. It is very simple.
Yeah, and all these things, Pythagoras developed these things too, because a triangle, math is about relationships. It's fixed. So math can be very useful because when you don't have a particular variable, you can find it out. Because relationship by relation, everything's related to everything. Our world is very mathematical. However, math can also be used to deceive, and that's the lesson of today.
But here is the problem that made people of that time doubt that the Earth is flat. Look at this diagram. This is the Earth, this is the sun, and these are the angles of the sun during the 12 hours of the day. If you are here at 75 degrees and a friend of yours is here, but on the other side at 75 degrees, the altitude of the sun will be 3,870 miles. So, if you want to do the same experiments with more people at the same time, but from other positions on Earth that are on the same line, they won't get the same results. And there is the problem. You and your friend will get the same distance as before, but the other people who are further away from each other will get smaller distances to the sun, even if they are all doing the experiments at the same time. The altitude of the sun will be lower for the second person, and for the third, it will be even lower, and so on and so forth.
So what's the problem? And we're going to repeat this over and over again so you really understand this experiment. The problem is that with 2 people, you can agree on a particular place for the sun. But once you have 3 or more, and you have basically people in different distances, everybody's seeing the sun at a different location. So this is a problem. This is why they say, well, the Earth must be curved. That's the only way possible. Of course, there's another explanation.
How is this possible? The angles should only intersect in one point because we only have one sun and not many suns. So how can other people see it at different altitudes? How does the sun set and rise? This graph was made by me based on real angles and real scales. So what would you do to solve this problem? Based on these results, if the Earth is flat, there may be no way to solve it. Let it be clear that the objective is just to understand this issue. We are not saying that the Earth is a globe. We know from many evidences that it is flat. In the next videos, we will talk about the problems of the ball, but for now, let's just continue with this topic. As I already mentioned, all angles have to intersect in one point. For example, if you are in a hallway and you put a spotlight in the middle, you walk away and measure the elevation angle of that spotlight, you will get the distance to it.
Do you see how this works? So this is just a light source, normal light source. And you have, this is looks like, what do you call them? Lighters that are put on a table. They all have a little shadow. And once you measure the length of that shadow, you can draw a line based on the angle from the top of the lighter and the shadow to the source of the light. All of them triangulate the position of the light source. That's the way these things work. However, with the sun, it's a little different because of refraction, and that's the thing to learn.
Which will be pointing directly at that spotlight. If you move further and do the same thing, you will get the exact distance to the spotlight. This is how it works. But when it comes to the sun, it doesn't work that way. So Eratosthenes, or whoever did this experiment for the first time, realized that the Earth could not be flat because of this specific problem. So they thought about curving the Earth downwards to make the geometry work, because it has to work one way or another. What happens when the Earth curves downwards?
Here's those elevation angles, right? Because different people at different places on the Earth see a different height for the sun. They see the sun in different positions. So what did they do? You're going to see what they did.
The angles of the elevation start to move upward. So what will happen if we keep bending it downwards? Eventually, these angles will become parallel to each other and will continue to coincide with reality, because by curving the Earth downwards, we don't change the shadows at all. In this case, we will have only one sun, because all these lines are pointing to one direction, because they are parallel to each other. This is why they tell us that the sun rays are parallel.
So you can see how he's going to do this. He's demonstrating it physically. Here's the plane of the Earth with these angles, right? Because different people at different places, the sun at a different position. That's the issue. That's why they say, well, the sun just must be 93 gajillion miles away and the Earth must be curved. Because the only way, not the only way, but the way that they make the angles work is by curving the surface of the Earth. You'll see. So these angles have a particular relationship that they need to maintain. Because remember, math is about relationships. So we need to maintain the relationships. Well, you can do that by curving the surface of the Earth. He's going to do it here in just a second. Okay, there you go. See how he's doing that? See how he's curving the surface of the Earth, and now the light rays are parallel, and the angles are all in alignment the way they're supposed to be.
In other words, they curve the Earth so that the angles start to make sense. So the question is, how much should we curve the Earth to make these lines parallel to each other without changing the angles, of course? Because these angles are immutable, as they can be measured in real life. What is the circumference that can make all these lines appear parallel and at the same time intersect at one point in the sky? How do we do that? It seems impossible. Parallel means they can't intersect, but we must make...
Parallel means that lines never intersect. Do you understand the problem? They say that the sun's rays are parallel because that's how the math works out. But parallel lines never intersect. Rays from any source of light always go outward from a point in the center of that light. They don't travel parallel to each other. You'll see some visual demonstrations of this. So how can you triangulate the position of the sun, even in heliocentrism, if your sun's rays are parallel? They'll never intersect, which is not...
Make them intersect, or the ball model will fail too. They told us that Eratosthenes measured the circumference of the Earth using shadows only. How did he do it? If you got the the angles, and you were smart enough to realize that after every 1037 miles, starting from the 90-degree angle, it is always 15 degrees minus. You will see a formula through these numbers and you will be able to make a shape out of it. Anyone with a simple math brain can do that. If you want to curve it down, you must create a circle with
This is AutoCAD, so he's using it again to show you how everything works with math.
this exact radius of 3,959 miles. And there is no other radius that will work for the ball Earth and match reality. And all you have to do is follow the mathematics of Eratosthenes. Let's explain it. We must take a circle and divide it into 24 equal parts. Each part represents 1 hour. It is the time we use today. And as I said before, humans created time. We chose the day to be 24 hours for some reason. So if we divide a circle into 24 hours, what will happen? No matter how big the circle is, all of these angles will remain the same. When you divide the circle by 24 hours, you get 15 degrees at each angle. Once you get this done, you will have to do something else. You have to draw a line from the center of the circle to the sun. So if you want to measure the angle of the sun, it will give you 90 degrees, no matter how big the circle or the ball is. This angle will be 90 degrees.
So you see, whenever in the ball model, because these rays are parallel hitting the Earth, there's always going to be one point that it's going to have degrees, right? And as you go over the curve of the Earth, these rays are going to create different angles, 75 degrees, 60 degrees, 45 degrees, and so on and so forth. So,
and this will always be 75 degrees, and this one 60 degrees, and so on and so forth, on all scales. So there will always be 15 degrees between each line. By doing this, we are already assuming that the light rays are parallel to each other. For now, this is the only way to make the angles work. So what do we do next? We need to know the actual circumference of the circle. If we assume that the Earth is a globe, then it has to have a circumference. How do we measure the circumference using the real angles of the sun? Here comes Eratosthenes, who supposedly calculated it 2,000 years ago. And today, we still use his math as a proof. What he did was measure the distance in real life between this 90-degree angle, Syene, and the second point on Earth, Alexandria. And then he measured the angle of it and did his famous math and got 25,000 miles. So yes, by knowing the circumference, all the elevation angles that we observe will begin to match reality. If you go anywhere in this circle, all you have to do is measure your angle, and if you compare it to real life, you will get exactly the same angle. It's really a cool idea, because you can tell where people are just by knowing their elevation angle and azimuth. You can also know what their angle of elevation is simply by knowing the distance to them. You can even draw the map of the Earth using these angles. And you don't even need a satellite or a plane to do it. Do you see the catch here? All people will think that this is the true model, even if they have never really seen the shape of the Earth. So imagine if we can make the angles work on a flat Earth. We will win the debate forever, because all the other evidences can support the flat Earth, but not this one. But after knowing the circumference,
the math works out. This is the problem. That again, math is about relationships, and you're going to learn why, even though the math works out on a ball, it's completely wrong.
Circumference of the Earth, the size can never be changed, because any change in the circumference will cause the angles to change too. But in real life, the angles cannot be changed, so no one can mess with the angles. This data is important because many people think that the globe may not be the size that we have been told and that it can be bigger. That is false, because if the ball is bigger, the real angles will not work on it. The angles of the sun in real life force us to have a single circumference, which is the one we use today.
Important point. Do you understand that? I'll repeat it, and we'll talk about a related point with the sun, because they recently in 2017 they found there was some eclipse mismatch. And so everybody was freaking out and saying, oh, the sun must be 250 times bigger than it actually is. Well, if it's 250 times bigger than it is, then all of the relationships change, folks. That means it has to be much farther away. That means the orbit of the Earth is much longer around the sun. Therefore, the entire model falls on its face. Do you understand? Relationships, math is about relationships. So if we want to say, well, the Earth is probably bigger, well, it can't be, because the angles of the sun, which were used to calculate the circumference of the Earth, which again, this is wrong. You're assuming the Earth is a sphere and calculating it that way. So of course it's going to work out because it's related to the angle of the sun. The angles of the sun are absolute. We can measure those very simply. Those do not change. Therefore, the result that you calculated cannot be changed. So if they ever say, well, the Earth is a little smaller, a little bigger, you can't, because the Earth, the size of the heliocentric Earth has to be fixed based on the angles of the sun.
Any change in size, the angles will start to change and will not match reality. So after discovering the circumference, they realized that they had a little problem. How can the sun rays reach Earth in parallel lines? If the sun is a circle or a ball, then all the light rays have to come from the center.
You see this? This is the problem. This has never been experimentally proven. This does not exist, where you have a spherical light source and light is emanating at parallel lines. When you see this, like you see a lot of heliocentric drawings, like, oh, okay, that's how it works. No, it doesn't. This is how it works. Light emanates from a point outward in basically in like a spherical fashion. It doesn't go in parallel lines, but yet the heliocentric model requires light to travel in parallel lines like this in order for the elevation angles of the sun to work, which is a conjecture. And of course, they'll probably say, well, it's a near parallel. For all intents and purposes, it's almost parallel. They intersect eventually because it's so far away. You know, it's like 93 million miles away. So they eventually intersect, which is nonsense. They either intersect or they don't. If they intersect, then the lines are actually at an angle. And so it's just clever math, folks. You have to understand these things.
That is to say, from one point as seen here. They clearly realize that light rays cannot be parallel because they must intersect in one point. So, for the math to work, the sun cannot be close to Earth because the further away you place the sun, the more parallel the angles will appear.
Emphasis on the word appear. They have to appear that they're parallel. It's all smoke and mirrors, folks. Again, this is conjecture. Oh, well, if the sun is really far away, then they're practically parallel. Well, no, they're either parallel or they're not. So again, it's just smoke and mirrors. Here's the same thing. You have the curve of the Earth, basically, supposedly. And these lines that represent the rays of the sun are hitting parallel. But again, this has never been empirically demonstrated. Never been empirically proven that lines from a spherical source travel like in a parallel sequence from that source. They just don't. It doesn't make any sense. And if the sun is so far away, think about how much nonsense that is. If the sun was, here we go. If the sun was so far away, they would be spreading out even more. Does that make sense?
Los rayos del sol, digamos, van a aparecer como paralelos, ¿no? Van a aparecer como paralelos desde nuestro punto de vista, desde la Tierra, pero van a cruzar.
But they will intersect at a point in the center of the source. Yeah, so if you actually were honest, then the lines intersect at a point. And if you've seen pictures of the sun through clouds, I mean, it's obvious there's a sun, but...
The size is not a problem because we already know the angular diameter of the sun, 0.52 degrees, because it can be measured by...
Angle of diameter meaning what is the size of it in your visual field when you look in the sky on average. That's angular diameter. We're going to be using that particular mathematical data to look at how their own heliocentric math debunks their models later in this episode.
Simple tools. So whenever we decide to put the sun, the angular diameter will help us calculate the size. So they have to put it as far as possible in the model so that we can see the light rays parallel to each other from Earth. So that means that if the sun is 93 million miles away...
Watch this animation. Do you see how if the sun was close, they have to go spread out like this? But then the farther this sun goes, you're going to see that in a DI model, they appear parallel. That's the illusion.
The difference between the parallel lines will be immeasurable. The further away the sun is, the better your math will work, and no one will know what they are doing. But if you ask them how they triangulated the sun, they will get nervous. because they will have to use the fake trip to the moon. They only need the size when it comes to an eclipse, but when it comes to angles, they only deal with the sun as a point, because the size of the sun can be determined as long as you have the distance. If you have the distance, you have the size. If you have the size, you have the distance. That's all.
Look at this drawing really quick so you understand what's being discussed. And again, this is another point that math is just math, folks. It's just relationships, okay? If the sun, know that the angular size, and it's another term that it's important to learn today, which is what is the size of something in your visual field, the angular size or the angular diameter. Everything has a particular space that it occupies in your visual field. The sun's angular diameter, on average, is 0.52 degrees, meaning it appears as a certain objective size in your visual field. But when you're looking, I mean, obviously don't look at the sun, but let's say the moon. Let's use the moon as an example. When you look at the moon, what are you looking at? You ever ask yourself, like, what am I looking at? How big is that thing actually? If it could be really, really close by and relatively small. Or it could be enormous and very, very far away. You have no way of knowing. The only way you would know is if you had an objective second witness. Does that make sense? When you look at the moon, if you had no context whatsoever, you don't know what you're looking at. This is the point. And so with this drawing, you can see, for example, in order to maintain the relationship of 0.52 angular size in your visual field, meaning how it appears, you can make the size whatever you want as long as you know the distance, or vice versa. If I know that the sun, for example, is 9,075 miles in diameter, that's just a number. Well, then the distance is, let's say, 1,000,000 miles. But if we say the sun needs to be 93 million miles away because the light rays will appear parallel, well, then the sun is, whatever. What's the sun size? Oh, I guess it's 844,000 miles across or whatever. Do you see the point? Like, you don't know what you're looking at. But the math works out because the math is about relationships. The angular size that you're looking at is still the same. It's still 0.52. All they've done is just change the numbers around and tell you, oh, the sun's actually really big. And you accept it without questioning the source and the assumptions.
So if you modify the distance, you have to modify the size. This is how it works. In fact, the distance to the sun has always changed throughout history. And
this is true. They've changed the sun's distance countless times.
every time they change the distance to the sun, they readjust everything else. But something strange happened in 2017 in the largest eclipse of the year over the United States. On August 21st, on their own website, they said that the duration of the eclipse is 5 hours. So if you do the calculations of the globe model, you will see that the eclipse should only last 4 hours and something. So with this eclipse, they have almost an hour to spare, and they know it. At that time, several NASA scientists began to say that the sun is much larger than they thought. They admitted that they need to increase the size of the sun to make the eclipse and the math match reality. The news came out in different media, and several notes were replicated. They said that the sun was 250 times bigger than the actual size they have told us.
I've pulled up some of these articles, and in the future, I think I found a few of them.
But now, those news articles disappeared from the internet, and all we can find now is that NASA scientists say that the size of the sun has to be a bit bigger so the eclipse calculations can work more precisely. This is very relevant because what they are clearly saying is that the size of the sun is a theory, and of course the distance to it is also a theory, but most people do not know about this. We know that the angular diameter of the sun and moon are equal to 0.52 degrees, and this can never be changed because anyone can measure it. So if you claim that the distance to the sun is exactly 93 million miles away, then the size has to be exactly 844,038 miles.
Do you get that? We know that this measurement, what we see, is empirical evidence. You can empirically measure the angular diameter of the sun, meaning how does it appear in the sky. This is an average because you have humidity and different things, like the moon can be huge sometimes. But on average, without any issues, the angular diameter is about 0.52 degrees, right? There's an objective thing that you can see empirically, if you have empirical proof. The theory part comes in where the story is explaining to you, well, how big is it? How far away is it? In order to achieve that angular size. Do you understand? One part of this is objective and measurable, while the other one is a story that they're telling you. So if they're changing the story about how big the sun is, well, it has to be a little bigger because we messed up on the eclipse prediction by an hour. It's got to be 250 times bigger. Do you realize the impact on everything that creates?
It can't be what they want. If they change the size, they will be forced to change the distance to keep the angular diameter as it is in real life. So right now, they are saying that for the math to work perfectly, the size of the sun has to be a few hundred miles larger than the actual size. But if you make the sun 250 times larger, you will put it so far away that the distance will be much greater, enormous. And what does that mean? If you change the distance, you would have a bigger problem. Because if the Earth orbits the sun, you are changing the radius of the Earth's orbit. Also, by changing the size of the sun, you would have to change the speed of the Earth. And by changing the speed of the Earth, you would have to change the speed of the moon because it orbits the Earth. You would also have to change the distance and the sizes of all planets. That is to say, if you change this and that, everything will be out of square and you will have to change the entire model.
Do you see the huge problem and why they tried to cover that up in 2017, where they totally goofed on that eclipse, and how if you change the size of the sun, everything has to change? That means the size of the orbit of the Earth changes and how long our years are supposed to be and seasons and everything else. So you can't. So that's the problem.
But they are too smart to do that in this era of internet. They will never change it because it would make everyone doubt the official science. So they better ignore it and not talk about it anymore. But we will not let that go. So the question is, did they teach us facts or just theories? If your calculations work, does it mean that the world we live in is exactly what your calculations say? The answer is no, because they are constantly contradicting their own calculations. Look what they said about the atmosphere. It's always been 300 miles up. They taught us that as a fact. But now they are saying that the atmosphere extends far beyond the moon.
Do you catch that? The atmosphere now extends far beyond the moon, i.e. there's an enclosure where the moon is, which is interesting.
So the globe model is not the truth. We can say that in some things it works better than the flat earth model. We can say that it is more accurate and the one we rely on today.
And by the way, probably the reason they did the atmosphere thing is because you can't actually launch rockets in space. There's the free expansion of gases principle, where in a vacuum, you're not going to have any thrust from a rocket. So they probably wised up to that and say, oh, well, actually, there's atmosphere all the way around the moon. That's how we got to the moon. Do you see just the constant shenanigans?
But is it the true shape of the Earth? Of course not. Also, you can't compare that model with ours because we barely started it a few years ago and we don't even have their budget. But let's get back to our topic. As we said at the beginning, the biggest problem with our model is the angles. Apparently, they don't work on the flat Earth, and we have to make them work. But how do we do that? This cannot be solved by playing with maps or discussing which map is correct or using flight durations, time zones, Coriolis effects, and so on. If we want to create a correct model, we have to solve the problem of the angles, because once the angles are in the right directions, the map will be accurate. If you fix the map, everything else will work. We must mathematically understand why this person sees the sun at this altitude, while this other person at the same time and in another position sees the sun at a different altitude. According to our studies, there are two options. One, curve the Earth downwards and make the light rays parallel to each other as we have seen. 2. Refraction.
Refraction is the reason why things work the way they do, not because the Earth is curved.
Curve the sky and create an individual curved sky for each eye and make it function as a concave lens, which distributes the light rays in a way that makes all the angles work as in the bulb model. This may sound strange, but I did it and it worked.
This is the experiment. They basically took a table with a light source, and you'll see when they added refraction, they were able to reproduce Eratosthenes' experiment and turn it into a ball with math, and the math works out fine. That's what we're going to be looking at today. Some people think that to triangulate the sun, we only need 2 sticks to measure the angle of elevation and the distance between the sticks. That would be correct to measure the distance between this lamp and the ground, but not to measure the distance between the sun and the earth. And what is the difference? When talking about the sun, you have to consider the atmosphere. Right here, there is no atmosphere, right? And what does the atmosphere do? Well, the atmosphere causes refraction. And what does this mean? Well, it means that the sun we see is not the real sun, but it's the apparent sun, which even the ball model acknowledges. Therefore, we cannot measure the distance to the apparent sun. Because it is a false image of the real sun, we cannot measure it. Which is true. This is the problem. Shnikes! Oh, shnikes. Okay, we're back. My goodness, it's a fun little adventure trying to track this one down again.
We published this video here 2 or 3 years ago. In the description you can find the link to it for further explanation, or visit my channel Decimal Z and see
We'll be watching that video a little bit later.
more videos. The experiment is summarized as follows. Imagine that you are standing on a big flat table and they tell you that you have to know the shape of that table using the shadows or the elevation angles, but you have no idea how high the light is. You should be able to tell that the table is flat because wherever you go, all the shadows intersect in the center of the light and you get the same distances. And knowing the elevation angles and the distances between objects can help you know how far away the light is. It is that easy because in this case there is no refraction that affects the light rays.
Do you understand that part? If there was no refraction, i.e. if there was no atmosphere or firmament or whatever else is up there causing this issue, it would be over. It would be super simple. You would just measure the angles, the elevation angles of whatever shadows are being created because the earth is flat, and you would be able to triangulate the exact position of the light source and its distance and so on. But there's refraction, and this is the problem.
Then imagine that you have to do the same, but they don't tell you that up there is a lens that refracts the light. When the refraction occurs, it becomes impossible to triangulate the light source, especially if you don't know which lens was used.
Do you see how this works? Here's the light from the light source emanating in different places, but it's hitting some sort of refractor. Now, who knows what this is? Speculate. We'll talk about that in throughout this series, but there is a firmament of something, whether it's immaterial or it's atmospheric or it's ether or it's maybe the water, who knows what it is, but there's something refracting the light. Those light rays, once they hit this medium, they disperse at different angles. So for example, if you see this in this drawing, this light ray, if you were here on this part of the table trying to use the angle to triangulate the position of the sun, you're going to get over here. In fact, you can see this little highlighter on my mouse is actually about the same size as the sun in this picture. Do you see the problem? So if you use this line, if you draw it all the way up, it's right about here. This is where the apparent sun would be. But the actual sun is here. Do you see the problem? So according to the angle that you see here through this lens, your sun is over here, but it's actually over here. Then this person, same thing. If this one tries to draw it, their angle is right about here. This one's over here, so it's a little bit closer. This one's super farther away. So everybody's getting a different answer for the position of the sun. That's why they made the earth curved and the light rays parallel to make the angles work. But in fact, actually what's really being curved is the refractor, whatever that is. We don't know the exact shape of the refractor, but something is refracting the lens and or the light, and that is what is causing these differences in the angles, in the positions. So anyway.
So you stand in there trying to triangulate the light using the same method as in the first part. You will realize that the lines will not intersect anywhere because of the refraction they did not tell you about. Then you will think that the shape of the table you are standing on is not flat. This is gonna be your answer if they didn't tell you anything about refraction that affects the light or the shadows you see. If you knew, you would have done a different math. If you are there at that big table without knowing that there is a lens that refracts the light above you, then according to to the calculations of Eratosthenes, you will think that you are standing on a ball and that the light source is very far away, which makes the light rays be parallel, because this is the only way to make your model work when refraction is the hidden key. The Eratosthenes calculations in this case that does not include refraction turned the flat table into a spherical table, which makes me think that it did the same thing to our flat Earth. The lens in the experiment is the atmosphere in reality. The atmosphere acts like a concave lens. How do we know this? There is a laser experiment that our team did which proves that the atmosphere makes light go upwards instead of downwards. Therefore, this theory must be taken into account.
The ball model says that it does it the other way around, that the atmosphere bends light downward because it needs to in order for them to justify the position of the sun being around the curve and so on. But if the Earth is a motionless plane, then the atmosphere makes things look up higher than they actually are. It's the other way around, actually.
The atmosphere acts like a lens. A lens can make the sun go down like this experiment by Rob Skiba. If you want to understand this better, you can watch the videos about how the sun and the stars rise and set on the flat Earth. So by bending the sky and squashing the Earth, you can fix the elevation angle issues, and I have already solved that. But there is still a bigger issue, which is the azimuth, but we are working on solving it. So first we need to make the angles work. We got questions like, is the real sun higher or lower than what it appears to be? Because even official science agrees that what we see is the apparent sun and not...
You see, this is the ball Earth explanation. So when you're looking outward over the horizon, you're seeing the apparent sun, but really the actual position is below the horizon, and it's projecting its light over the curve, just like how they do with the ships. See, oh, it's just refraction over the curve of the ocean that's bringing that image to light, which is, of course, is nonsense. It's been proven wrong so many times. It's the other way around, whereas the surface of the Earth is flat, and the sun is higher than it actually is when you see it. So, I mean, who knows how exactly it's behaving? That's the mystery. That's why I don't make any claims about the position of the sun, and neither should you, but you should understand that it's local and not some giant ball of gas.
Not the real sun. This is another thing that makes you wonder how they could measure the distance to the real sun if we only see a reflection of it. If we just see an apparent sun, then the sun cannot be triangulated. Therefore, the distance to it should remain unknown.
Yeah, did you get that? Like, if they ignore, this is the problem. And again, this is so you can debunk their own model with their own claims. They claim that when you look at the sun, you're actually not seeing the real sun. You're seeing the apparent sun, right? So it's going through that refraction and over the curve, and so you're seeing a reflection of it of some kind. Okay, well, that's possible. There's certainly evidence that there is refraction. But if that's the case, how can you possibly triangulate the distance of the sun? How do you know the position? How do you know the size? How do you know any of these things? You can't. If you're acknowledging that refraction is causing these effects, then Eratosthenes' experiment, everything you've built your model on, is bunk. It's debunked.
If those angles had intersected at one point from the beginning, then the flat Earth wouldn't have been a problem and the globe theory wouldn't have been considered. The story of Eratosthenes may be a lie, but whether it is a lie or not, the geometry of the globe does not change. Anyone with a knowledge of geometry would have no problem knowing the circumference of a globe or a circle. That story might have been created to make us think that the globe Earth theory has been calculated 2,000 years ago, therefore it is correct. But there are many reasons to doubt that experiment was real. By understanding this, we can know the aspects that must be studied and taken into account when creating an accurate model of the flat Earth, which better demonstrates reality and helps us understand the world as it is.
So that's it for that first one. Great videos from Decimal Z as far as the cosmological stuff, and he's got some we're going to be looking at these various experiments. But conclusion from this first one is that the triangulation problem, meaning 3 points where people can't triangulate the position of the sun. Remember, one angle goes one place, one angle goes another. You're never going to get a singular point, which doesn't make sense. Well, it does make sense because of refraction. Refraction is refracting the light that you see, and the sun that you see is not the actual sun. Meaning you're not seeing the position of the sun objectively. You're seeing a refracted image, which is very fascinating. The question is, how much is it being refracted? Where is the actual sun? And then so on and so forth. We can explore some of those things in later videos, but that's the problem. Eratosthenes never accounted for refraction. So, because he didn't account for refraction, he just assumed that the Earth must be curved in order to make the math work. Of course, he had no reason to account for refraction. People didn't really consider refraction or the behavior of light or the ether that way. Those things hadn't been discovered yet or documented. They didn't discover like the pattern of light waves from a spherical source, or the fact that light doesn't travel parallel lines. It travels outward from a point in the source, and so on and so forth. So anyway, he didn't have any reason to factor refraction. They didn't discover those things yet. He also had a lot of bias from traditions of men, right? With Plato and Pythagoras and all the spherical obsession they had. So ultimately, there was a lot of bias there. The occultists in general worship the sun as the central deity. And so you'll see that when we look at the heliocentric conspiracy. Copernicus, all these people were very like sun-worshipping type of people. It's pretty crazy. Again, you cannot divorce heliocentrism from mysticism. It's a religion, folks. You need to get it in your mind. I know it sounds crazy, but they've just dressed this religion up with science, and it's not even good science. So he had no reason to believe, he had no reason to suspect the refractive issue. And because of his bias and all of the occult stuff that he was involved with, it was a very easy thing for him to assume that the Earth was a circle and the sun must be big and far away. Of course, today, again, heliocentrism argues refraction, as you clearly saw with the model of the apparent sun higher than the actual sun below the horizon and so on. And of course, they argue these things because they have to, but it disproves their model. Do you understand? If you're going to argue refraction that's that significant, then the entire point of Eratosthenes' discoveries is called into question, because there are other ways to explain what he solved, which is that he's having a flat, motionless plane with a local light source being refracted. That is an equally possible explanation. And you will see through experimental proof, which we're going to document in this episode, that that is the case. Of course, if refraction exists, it makes a significant difference. And it does exist because they admit it to you that they exist. But of course, ever since it got discovered, they've never applied it to Eratosthenes. You see all those places we talked about with the documenting his experiment, whatever, nobody mentions refraction. Nobody. Oh, well, he had certain errors with the stadium measurement. Yeah. But what about the error of refraction? You ever think about that? How come they never talk about refraction when it comes to the things that destroy their model? But it comes when they debate like flat earthers or whatever. They say, oh, what you're seeing when you look at a boat crossing the ocean and it's really far away and it disappears, you're just seeing refraction because it's going over the curve. Okay. Well, you're not, because there are certain atmospheric effects that happen, but you can bring boats back into view, which would be impossible if it was actually going physically over the curve. But if you're because that happens also on land too. Now, land you can argue with the water, oh, there's humidity and all these atmospheric effects, but what about land? Land does the same thing too. Land is not going to create a mirage that brings it back over the curve hundreds of miles. It's nonsense. So yet, if you're going to argue refraction, then why don't you be consistent and realize that refraction actually refutes your model? Because it refutes Eratosthenes and it refutes this entire idea of the solar angle being a result of the curvature of the Earth. It's a result of the curvature of the heavens. Do you get it? One is straight and one is curved. Math is about relationships. What they did is they inverted the relationship. It's still a relationship, so the math works out fine. They made the sun's rays parallel and straight, and the earth curved, where in fact the earth is straight and the heavens are curved, which makes the sun's rays go in different directions. So anyway, we'll talk more about that. But we'll watch the experiment. You can watch it as well on his channel with the table and the local light source, where they do it with the local light source, and you can be able to triangulate the position of the light source very easily. Then they add a lens, a refractory lens, and you can see that they get the same exact problem as with the earth, which is very interesting too, because then it makes you wonder, what is the shape of the firmament if there is a solid firmament to begin with. When there's no lens, you don't have the shadow problem. But there is a lens, and that's the problem. That's why there's a refraction issue, that's why there's the triangulation issue. And of course, if you curve the surface of the earth and you flatten the light rays, make them parallel, the math works out fine. That's the brilliance of this spell, and why people don't understand, but why people get so easily swayed, because math they think is objectively true. So, oh, there you go. If you make something mathematized, then it must be true. It's not. It's just math, folks. It's just relationships. They made the sun so ridiculously huge and far away, which is a conjecture, so that the math could work out and nobody would ever question it. Say, oh, it's practically parallel. So then, the meaning, the difference between angles is meaningless. Well, no, because the angles have to be exact. The sun is objectively casting certain angles. And of course, again, if you can make it so far away and so ridiculously huge that it just seems like it kind of hits parallel and everything just kind of works, but it doesn't. Because you saw from the 2017 event that they had to change the size of the sun. And of course, if that changes, everything changes, which of course destroys their model. Now, the problem is, with the heliocentric model, how can you triangulate the sun if the sun's rays are parallel? How can you do it? You can't. And if you change the size of the sun, of course, the entire model collapses. The experiment that this guy does, which we'll watch, proves that you can turn a flat surface into a ball with math, and the math works out fine without any errors, even though what you're representing with that math is not the truth. Do you understand? And you're going to see it for yourself. People, they've done this experiment with a refractory lens, creating the same angles and the same proportions, curving the surface instead of basically curving the lens, right? So you've taken the curve from somewhere. The curve is in the lens. You refuse to acknowledge it, so you have to do it. You have to put it somewhere, meaning you put it on the surface of the earth. So they've recreated this error of Eratosthenes and proven that you can represent a flat reality as a ball with mathematics, and everything works out perfectly. But it's a lie. Do you understand? And you're going to see that for yourself today, because math is just about relationships. Eratosthenes made a great error because he ignored refraction, and he made the light straight and the earth curved. So as a result of ignoring the curve of the firmament, or whatever the curve is, it has to go somewhere, because math has to remain the same. When you're solving a math equation, one side has to equal the other. Do you understand? Math is about relationships. I'm going to say it over and over again. 4 equals 2 plus 2. You can't have 4 equals 2 plus 3. I have to subtract 1 from the 3 in order to have 2 plus 2 again. The relationship has to work. So, if you have something that's curved and something that's straight, meaning the heavens are curved in some way, they're refracting, and the earth is flat, the other way to represent that mathematically, not that it's true, but there's a way that you can represent this mathematically, is by flipping it around, curving the earth and straightening the lines of the sun, right? So that way everything works out. So the lines being parallel of the sun are, in effect, doing the same thing that the earth being straight and flat does in a flat model. It's the same thing. It's just like writing an equation like this. 2 plus 2 equals 4, right? The equal sign is the divider between the two sides. You can also write that equation as 4 equals 2 plus 2. Does that make sense? Now, of course, in math, you could argue that both are equivalent equations and expressions. And this is the problem. This is the problem with math. Both of those equations are true. 2 plus 2 is 4. 4 equals 2 plus 2. They're two different expressions of the same thing. However, when you transfer that into a real empirical physical world, one of the models is not true, even though it's mathematically true. Do you understand? The Earth can't be both a flat, motionless plane with a local light source and a spherical Earth with a huge light source far away. Both of those expressions mathematically are explaining to you what seems to happen, yet one of them is true and one of them is false. They can't coexist at the same time, and this is the problem. Now, the next video I want to show you is on refraction. It's about 6 minutes, and basically how they were able to reproduce using a very sophisticated astronomical program and simulation program. Using atmospheric data, they were able to reproduce the same data that you receive from a heliocentric model and the angles and so on by factoring in atmospheric data that's available that you can import into their simulation. So now this is going to be from 2 minutes and let's see, 52, somewhere around here. Let's go from here.
Does. And we can prove that too.
Modern science claims that the apparent sun sets after the real sun because of the atmosphere and the effect of refraction. So when we see the apparent sun above the horizon line, that is just a reflection of the real sun, which is already set. But when we added the atmosphere to the globe model, it did the same thing that it did on the flat Earth model. The apparent sun goes down first, and the real sun follows it. That is contrary to the way refraction is normally presented.
Remember, refraction works the opposite way that they're telling you it does. They're telling you it does because they need it for their ball model to explain the setting of the sun. But in fact, refraction is the other way around.
So the atmosphere is something that we can't ignore. It's like looking at the sun with your glasses on. The atmosphere is like a lens with no cover. We are like fish in the sea, you know. So the atmosphere can change the whole view of the sun. Now, in order to prove this, we had to add the atmosphere to Steve's model, but the question was how? It was not an easy thing to do, and by coincidence, Steve found out that his program is capable to model the atmosphere exactly how it is. So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything. The sun started to rise and set, and it started to match reality more than the globe model does.
With 3D software, you can model the atmosphere very accurately using refraction settings. We're not talking about drawing it and making it visible. We're talking about drawing the layers with their real effects on sunlight. Once I discovered it, I told my team, guys, we've got a solution. We can test the atmosphere's effect on the light.
After we had everything fixed, we started to compare it with real life. We actually took some real sunset videos and compared them with both the flat Earth model and the globe Earth model. And guess what? If you play the 3 videos...
This is, I forget which one it is. I think this is real life, then one of them is the globe model, one of them is the flat model. So again, there's multiple ways to explain something. One of them is because you can't have the globe and the flat model simultaneously exist. So one of them is the truth, and they all match reality.
At the same time, you would not know where the flat Earth model is because it really looks like real live videos.
Many scientists think that the flat Earth model can't work because it can't represent sunrise and sunset. What are they going to say after studying this proof? Is it going to make sense to some of them now? They can't ignore the atmosphere. And all we did to make the flat Earth model work was add the atmosphere exactly how science represents it. We didn't make it up.
Now, solving this problem doesn't mean that we solved everything. We still have a problem with the elevation angles. Because the sun that we see is not in its real position. What we see is just the apparent sun. So imagine the real sun is here and the fake sun is here. The shadow that you're going to get is going to follow the apparent sun and not the real sun, and this is not what we want.
Okay, so the elevation angle that you're gonna measure with the sextant or with any other tool is not the angle of the real position of the sun. It's just the angle of the apparent sun. And we're still working on how to locate the real sun that we never see. Once we locate it, we will be able to get the exact elevation angles of the real position of the sun. And by doing that, we can draw the flat earth map from scratch. I couldn't continue drawing the flat earth map with the triangulation method that I talked about a few months ago, if you remember, because I found out that I was triangulating a fake position of the sun. So triangulating the sun from 3 different positions is like triangulating 3 suns at the same time, and that will never ever give you a precise number. So that is why I stopped plotting the map, and right now I'm just focusing on how to locate the real position of the sun.
That's the problem. The problem is, how do you triangulate the actual sun? Because every time you are using the shadow angle measurement, you're really just triangulating the sun that you see, which is the apparent sun. It's a refraction of the actual sun. Do you get it? That's the problem. And so the thing he's trying to do, which I think is actually an interesting thing, although it'll be interesting to see if that's actually even possible. But let's say, assuming he could figure out the actual position of the sun, and then based off of that and the elevation angles and the angles that it's creating on different shadows, you could then go objectively to different places on the earth that we know where we can measure these angles and recreate the map of the earth based off of that. That would be much more accurate, because the Gleason map is not true. The circle map is not true. Although, again, that's the thing that I wonder, is if he actually does find that information, would he assume that the earth is a circle? There you go again with the assumptions. But the Gleason map is just, it's a globe that's basically an azimuthal projection, meaning it's outward, and so it breaks down in the southern hemisphere. And you're going to see that. The earth it cannot be a circle. Either way, it's an interesting experiment idea, but the problem is that you cannot triangulate the actual position of the sun because of the firmament.
When the sun is directly overhead, the refraction is near 0, but you still can't say where the sun actually is. As the sun travels towards the west, the atmosphere creates an image of it for every eye. So anyone who looks at the sun from the same angle as you, but from a different city, will see the apparent sun in a different position. But no one can see the sun in its real position. So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow.
Notice also how the sun goes like this in straight lines. This is just perspective because it's traveling down a track. It's not curving as they tell you. We'll talk about this more in a future episode, but the sun doesn't do this arc thing across the sky. It goes straight. There's a straight track that is always going on. Which, of course, the Baugh model explains to you, because it says, well, the sun's huge and you're just orbiting around, you're revolving around the axis, and that's why the sun just goes on a straight track across the sky. Of course, they say that the sun arcs too, which is not true, but the circle map cannot explain the straightness of the sun's track across the sky. This is one of the refuting points.
This is how the sunrise and sunset started to work on the flat Earth once the atmosphere was added. In the description, you will find a link to the original video. Compare it with this one and make your own conclusions.
And again, this whole circle thing around the Earth, this is not how it works. It can't. It just simply can't.
We were planning to...
But you can see as far as from the eye level view, the horizon view, that it looks the same given the atmospheric effects. So this can be simulated just like the globe can simulate their model. And so there are multiple ways to explain the same thing. Obviously, you should know that from the previous episode too, with the ancients and how they predicted so many celestial events using a model that was very different than the one that we use today. So, this guy's already started. Conclusion. Well, what do we take from these short little video? Well, refraction is very real. It gets worse the lower the sun gets on our horizon, right? When it's above, it's still being refracted, but not as much. Still, you can't triangulate the position of the sun, even if you are on the Tropic of Capricorn on the summer solstice, or the Tropic of Cancer, sorry, either one, I guess. You were there and you were able to look directly at the sun overhead, you would still have some refraction. But as the sun progresses in its circuit, in its course through the sky, the refraction gets worse and worse. And so this is a problem. Now, the thing that the heliocentric model tells you is that the sun, the apparent sun, is higher than the actual sun. Meaning when you look, let's say it's sunset, and you see the sun at the horizon, what you're actually seeing is what they're telling you is the apparent sun. The actual sun is already set beyond the curve of the earth, however many minutes later or earlier. So you're just seeing a refracted image. Whereas if the earth is flat, it's a flat motionless plane, what you're seeing is an apparent sun, but the real sun is actually higher because it's the source sun. Does that make sense? The source is higher than the refraction. We'll look at some diagrams in future episodes, but imagine that it's the opposite way that they're telling you. They admit that there's refraction, and if that's the case, and it's creating these drastic effects where you can't triangulate the position of the sun, then the entire model falls apart. And certainly Eratosthenes' calculations fall apart too. They need it to be below the curve of the earth because their model creates the setting of the sun based on a physical movement of the earth, right? So the earth is rotating, and as a result, you perceive from the earth that the sun is basically going beyond the curve. So they need refraction to work downward, but that's not how refraction works. And that there's proof of that. There's experimental proof that they did with lasers that shows you refraction actually goes up. The atmosphere causes light to move upwards, which is very fascinating. And that that makes total sense on a flat plane with a local light source where you have, here's the sun, the real sun, and here's the refracted image. As it's going over the dome, you're over here where this microphone is at, let's say, and you're seeing the image of the sun, but the real sun is over here somewhere higher than the actual thing that you're seeing. Does that make sense? Hopefully it makes sense. I know that I didn't plan a drawing for it, but we will look at some drawings in the future. Well, actually, when we debunk the circle map, we'll be looking at this extensively at the whole refraction problem, because refraction is also a problem for the circle map. But anyway, if refraction is that significant, why has nobody questioned Eratosthenes' results? Why is it that every time these people present to you, like Carl Sagan or Neil deGrasse Tyson, and they go on with their charming little entertainment and their story time, bedtime hour for the kids, why do they never mention refraction? They make it seem as if the sun's rays hitting the earth are not going through any sort of refraction whatsoever, and it's just completely objective information, where of course that's not true. And you will see experimental proof of it in the next video. Nobody can see the real sun because of refraction, but the same result can be recreated on a flat plane with a local light source being refracted through a curved lens. And you're going to see proof of that in this next video. This is called Globe Math, Flat Earth, Globe Earth Mathematically Debunked. So you're going to see, this next one's also about 20 minutes, 25 minutes, a little bit longer, but it's a great video. It reviews the experiment that he did with the table in more detail, so I wanted to show it to you again to document it so that you have proof. Don't worry if you don't understand all of this. It's actually quite simple. We'll put it together and hopefully it'll make sense. We're also going to see the experiment with the lens and how they took the math and basically made a table into a ball using math, and nobody's the wiser. And that's the point of today. So this one goes from, let's see, 6 minutes. Where's my 6-minute mark? Okay. And lights, camera, action.
Table. We got an A3 paper on it and 9 nails, as you can see. Imagine you are on that paper, and that paper is the earth. And this bulb is the sun. It's 50 centimeters above the table. It's exactly 90 degrees above the nail in the middle. All the nails are 5 centimeters except the one in the middle. And the distance between each nail is written on the paper, as you can see here. Our units of measure is centimeters, okay? Some people think...
And you can download this information and check it for yourself and recreate it for yourself and and measure it yourself. Be a scientist if you doubt this.
Think that if you use more than 3 objects, you would not be able to triangulate the bulb. They're wrong. If you model it and do it in real life, you will get the same results. All the elevation angles, or better said light's rays, come from the center of the bulb, and all the depression angles go to the tip of the shadows. So light rays of the experiment should intersect in the bulb. Here are the measurements that we got in AutoCAD. But of course, this is just a 3D program. Now we're gonna do the same exact thing in real life, and we will get the same length of the shadows. And I am so sorry that I have no way to prove to you that we are not faking these experiments. Well, I guess there is only one way to find out. You're gonna have to do it yourself. Don't trust me, trust yourself. Here are the guys who did the experiments: AG and Ibam and Ayat and Damar. So here is the experiments. The nails are 5 centimeters long. The one in the middle was put there just to demonstrate that the bulb is 90 degrees above it. And as you can see, it has no shadow at all.
So they're basically recreating Eratosthenes' experiment, where you have a 90-degree relationship between one point of reference, like the well that he saw where the sun on the summer solstice, and other points of reference that creates various shadow lengths. And now this is the first time they did it, there's no refraction. So you can, using the shadow lengths of all of these different sources, you can triangulate the source of the light because there's no refraction, meaning the light that you see is the light that you see. Does that make sense? It's not being, altered in some way.
The farthest nail is 15 centimeters away from the center, and the closest is 5 centimeters away from the center, and the last one is 10 centimeters away. We used 9 nails and 3 distances because the lens was not big enough. They put the 5 centimeter nails and the bulb in the appropriate distances, and here are the measurements of each shadow. Please compare them to the results of the 3D model that you got on the screen. If you do this correctly, you will get a very precise results. I did this before, and people who have been following me already know it. So if you are new and you want to watch this with great detail, just click on this link right here and watch my other video. You will find the link in the description. The 3D model here matched reality so accurately. All the shadows that I got in the 3D model matched the shadows that we got on this table. And as I said before, that was just part 1. Wait for part 2. Now, if we were Eratosthenes' friends and wanted to do the same thing with the sun in real life, our experiments would fail. We would not be able to triangulate the sun. The cones or the lines that we would draw to triangulate the sun would not intersect in one point like in the 3D model that I just showed you. And
see the problem? I mean, again, this is a circular Earth, by the way. They're trying to triangulate the sun, and you can't because you get different angles because of refraction.
this is going to make us think that the Earth is not flat, because the triangulations worked on the experiments that we did on the flat table, but did not work on the sun in real life. So something must be wrong. You would think, what is it? This must mean that the Earth is not flat. So if we really were those scientists, you would have to think about something else, like the Earth being a globe, for example. Yeah. So this is how they came up with the globe theory. The angles of elevation led them to think about the globe model. They were just assumptions based on mathematics. Forgive me, but I'm going to say this one more time. If you use more than 3 positions to triangulate the sun, assuming that the Earth is flat, your triangulation will never work. No matter how hard you try, you will always fail. The sun rays will never intersect in one point. I have been doing this for a long time and I had to come to this conclusion. Some of you might think that if the distances between the objects are not accurate, then the triangulation will not work. And I agree with that, but even if the distances were 100% accurate, the triangulations would never work. And I'm gonna prove what I'm saying with another experiment.
As we said in the previous videos about refraction, the sun is never in its real position. Even modern science agrees with us. What you are triangulating is a reflection of the sun, and this is why your triangulation will never work. Imagine yourself in the bottom of a swimming pool trying to triangulate a bulb that is above the water. You will never be able to triangulate it unless you know how refraction works.
Now imagine, I mean, this is, who knows what the firmament really is, but this is an accurate idea. It's like, imagine you're under the pool here, you're looking at somebody like a flashlight at you. It would be impossible to understand exactly where the point of origin is because the water is dispersing the light.
On water. The experiments will explain this better. Just stay with us. So Eratosthenes and his friends decided that the Earth is not flat because there was no way to make the angles of elevation work and make sense. For example, whenever they triangulate the sun from two positions, the distance to the sun appears to be around 3,000 miles. And at the same time they triangulate it from two other positions and they get a distance of 4,000 miles. Solving this at that time was impossible, and it was still impossible to us until a few months ago. Anyways, these mathematicians had to find a way to make these angles work, so they assumed that the Earth is a globe and the sun rays come to Earth in parallel lines, because this was the only way to make the angles work. So their only problem was how to know the circumference of the Earth so that angles can work perfectly. Eratosthenes supposedly had this brilliant idea. There was a well in Syene in Egypt, and the sun used to pass directly above it once a year, which means that the sun at that time was 90 degrees above that well. The next year, at the same time and date, he went to Alexandria and he placed a stick on the ground, and he noticed that the stick had a shadow. So he measured this angle of deception, and it was 7.2 degrees. So he thought that the Earth must be a sphere and that he could calculate it. He just needed to know the distance between Syene and Alexandria. So he sent a guy to measure the distance, which was about 5,000 miles or 800 kilometers. So this angle right here, 7.2, has to be equal to the central angle of any sphere, and that made everything else easy for him. A sphere is 360 degrees, so all he had to do is divide 360 by the angle of deception, which was 7.2 degrees, to get 50. So if we draw a circle like this and draw a line like this and repeat it 50 times, it will give us this angle, 7.2 degrees between each two lines. So in order to get the circumference of the Earth, he had to multiply 50 by the distance, which was 500 miles, and he got 25,000 miles or 40,000 kilometers. So that has been the circumference of the Earth since that time, which is really precise for someone who had no equipment at all. Very smart move, NASA. All you had to do was correct the calculations a bit more, and that's it. Now the math works beautifully on this new circumference of the globe Earth, 24,900 miles. I wonder if you were a scientist and you wanted to prove that the Earth is a globe, would you just do one experiment and that's it? Did this guy Eratosthenes repeat this experiment many times in different places before assuming it's a globe? Okay, doesn't matter now, let's just believe it. Okay, let me show you how the angles work on the globe model. It doesn't matter how big the globe is. The angles will work the same, but we will use this exact radius of the Earth, 3,959 miles. I'm gonna divide the Earth into 24 parts because it takes the Earth 24 hours to rotate. So, here is the distance between each point. And that means that if you are here, your elevation angle will be 90 degrees because the sun is right above your head.
That was the well in Syene on this solstice, where he said, okay, that's an objective point. The sun is right above there. And then he measured the distance to the other place. And the angle, he understood that, okay, that must be a certain amount of curve over a certain amount of surface area and so on.
So imagine you got friends all over the globe. Your friend right here would not have the sun directly overhead because he is 1 hour away from you. So his elevation angle is going to be 75 degrees because the Earth rotates 15 degrees every hour. So every hour you will have 15 degrees less.
here you're gonna have 75 degrees, and here you're gonna have 60 degrees, and here 45 degrees, and so on. If this is confusing, then here is an easy way to know if this is accurate. Please go to suncock.org and go to the equator and make sure your latitude is around 0 degrees. You can change the date to the 21st March because the sun is above the equator at that time. And also change the time to 1 p.m. UTC plus 1. And then try to click around to find the 90-degree angle of the sun. Once you find it, change the time from 1 p.m. to 2 p.m. and you should get 75 degrees in the altitude of the sun. Now, if you...
This is from suncalc.org, so it's an official website you can check for yourself as well.
Change it to 3 p.m., you should get 60 degrees. So this is how the angles of elevation work on the globe. If we can make these angles work on the flat Earth model, we will be able to know the degrees and the distances between each position on Earth.
So the angles, just to review, the sun's elevation angle, meaning how high is it in the sky, your relative position when you're looking at it. At noon, assuming, let's say on the Tropic of Cancer, right underneath the sun at noon o'clock, you would look up and it's 90 degrees, right? That's the elevation angle. But somebody who is a certain distance away from you, it wouldn't be noon over there, right? Let's say it's 11 o'clock in the morning, or let's say it's 1 p.m., depending on whether they're east or west of you. They would see the sun at a slightly different angle at 75 degrees. Somebody who's, 2 or 3 hours away or whatever might see it at 60 degrees. It's a little bit lower in the sky. Whether it's later or earlier doesn't matter because the sun has a particular path that it goes through the sky. So the sun has a fixed, this is objective empirical evidence that the sun has, every hour, it is 15 degrees at a different height in the sky. So the question is, how can that be reproduced on a flat surface where you have basically refraction? And he's going to reproduce it for you.
And that will help us draw an accurate flat Earth map, and our map will be undebunkable. So, to everyone who work on the flat Earth map, please, forget about the flight's duration and time zones. They will never ever help you draw an accurate map. Focus only on the angles of elevation and the horizontal angles, or what we call azimuth. And we're gonna talk about this in detail in the future. Now let's get back to what we have been doing. Do you realize now the weakness of the flat Earth? If yes, then you will love what's coming next. Eratosthenes had no idea what the atmosphere is, so he just assumed that the sun...
Look at this light. Look at this light here and watch what happens.
...light comes in straight parallel lines to make his math work.
See? Boom, how the light just goes much higher. So you have a source that's at a real level, then you have an apparent level. And if you're past that, in this case, right? What you're going to see is a very different reality.
And it did work. Now we know that the atmosphere bends the light. So if the sunlight really bends, then how come Eratosthenes' math is correct?
Notice also the closer he got to the source, or I should say the closer he got to the firmament, the less the refraction was. Because the farther you are away, the waves are traveling farther and farther in space through the atmosphere, through so on. And so the farther you are away, the more refraction there is. That's why when the sun is setting or rising, it's the farthest away from you. Does that make sense? However the position the sun is, who knows how exactly high it is or what position it is. But when it's rising or setting, meaning early morning or late afternoon, it's the greatest amount of refraction because it's the farthest away from you. The lines of the rays of the sun are traveling through the most amount of atmosphere. Whereas when it's right above, it's 90 degrees. So it's still refracting, but not as significantly.
It doesn't make any sense. His math was based on straight lines. So I believe that in order to save the globe model, our scientists told us that the atmosphere bends the light, but it's almost unnoticeable. So if the apparent sun is right above the horizon line, that means that the real sun is right below it, and the angle between them is around 0.84 degrees approximately. So, are we supposed to believe this without any experiments to back up their claim? To me, this is just an assumption. The air is full of water and gases, and we know that water affects the light a lot.
The air sometimes magnifies objects. It makes them look bigger and closer. Sometimes it works like water, sometimes it doesn't. We really don't know what it is or how it works. So scientists, please stop making up assumptions based on numbers.
Yeah, this is all just theory. They tell you, oh, the sun is actually doing this, and it's below the horizon when you're seeing it set. So the real sun is already set, basically. The angle's about 0.4 degrees between the two, between the apparent sun and the. But where do they get that from? You ever ask yourself, like, they never measured that? How could they possibly measure where the real sun is if they can't triangulate the sun? It's all just theory. It's all just theory, and of course they've done it in such a way to where they acknowledge refraction when it suits them to try to basically debunk your proofs for a flat horizon, which of course they can't be debunked because of flat horizon. Especially now with all the technology, everybody's proving that the horizon is flat. But they use that refraction there. But then when it comes to their model, oh, refraction is not that significant. It's only this 0.84 degrees and so on. Like, where do you get that number from? How do you know how significant refraction is? That's the question. Because if it was significant, then it calls into question the whole model. Do you get it? So they have to make it seem that it's not significant.
Okay, right now we're gonna redo Eratosthenes' experiments, but this time we will use refraction. The difference between part 1 and part 2 is refraction, so we added a concave lens to represent the atmosphere. The rest is still the same. And no, we are not saying that the atmosphere is concave. We don't know what it is. Each lens will give you an interesting result, so we chose a concave lens. So please focus on this, because it's gonna blow your mind. I'm gonna do my best to make it as easy as possible to understand. So the concave lens is 30 centimeters above the table and the bulb is still at the same height, 50 centimeters. The nail that is in the center of the paper is 90 degrees below the lens and the bulb. That is why it has no shadow at all. We put it there just to make sure it is 90 degrees below the bulb. The distance between each object is still the same as before, but as you can see now, the shadows are longer than before thanks to the concave lens. And this is what a concave lens does to the light. It makes light rays diverge and...
You see that? So here's the light that comes through and it diverges them based on the shape of the lens. Obviously, we don't know what the shape of the lens is that's diverging the sun, but something's being diverged because of refraction.
This is why the shadows become longer. Okay, let's watch the experiment. I'm gonna put all the details on the screen because it's hard to see the numbers, okay? So we're gonna start with 10 centimeters distance. Before adding the lens, the shadow was 1 centimeters and now it's 1.7 centimeters. It's longer now than before. This nail right here is also 10 centimeters away from the center. And its shadow is the same as the previous one, 1.7 centimeters. This one is 5 centimeters away from the center. And before adding the lens, the shadow was 0.5 centimeters and now it's 0.83 centimeters.
So you see, the lens changes the length of the shadows. Now you're running into the same problem that you have with the sun and the earth.
This one is the farthest and it's 15 centimeters away from the center. Its shadow before adding the lens was 1.5 centimeters and now it's 2.69 centimeters. We're using 2 decimals to show you how precise this can be on the globe table that you're gonna see later. This shadow is the same as the previous one, 2.69 centimeters. This nail is also 10 centimeters away from the center. and its shadow is also 1.7 centimeters. And this is another one that is also 10 centimeters away from the center, and its shadow is also 1.7 centimeters.
Notice how, because the shape of the lens is concave, it creates a predictable pattern in the distances. All the nails that are the same distance have the same alteration to their shadows, right? So the close ones moved up from like 1 centimeter to 1.7. The other ones that were farther away, they had the same length of shadows being changed. Even though they're different now because of the lens, the change to them was the same because the surface of the lens is uniform, which is interesting because what that would suggest is that, my point is that maybe the lens that the sun is going through is also uniform. It's a uniform shape in some way.
The last one is 5 centimeters away from the center, and its shadow is 0.83 centimeters. As you can see, even if we changed the directions of the nails, they had the same shadow. So the distances we are going to work with are 5, 10, and 15 centimeters. And the shadows we're going to work with are 0.83, 1.7, and 2.69 centimeters. Okay? So right now we are going to run a few tests. The first one is going to be triangulating the bulb using these long shadows. So to triangulate it, I'm going to have to model everything and make our math simple and easy to understand. So this is what I did. I draw the same thing you see on the table, and I draw a line from the tip of each shadow to the tip of each nail, and I just made the line longer to see where all these lines are going to intersect. Because if the light rays are coming from the bulb, then all the lines will intersect in the bulb like in the first experiment, right? But as you can see here, the light rays are not intersecting in the bulb, but they all go through the lens. So that means that the lens is what is causing the shadows to become longer. Now imagine yourself so small on this paper, and you are trying to triangulate the bulb, but you have no idea if there is any lens in the sky, because you just can't see it like you can't see the atmosphere. So your triangulations will always fail, because they will always give you a different distance to the bulb, because the bulb is not what you think it is. You are just triangulating a reflection of it. If you were so small on that paper, then the lights you will see is just another image of the lights that is projecting somewhere on the lens. But from the table you cannot see it. So if you don't consider the lens, your math will not be correct, even if you make it work. Please imagine
That's the point of today.
Eratosthenes is on that table right now looking at the bulb through that lens. Can he see where the real bulb is? Of course not. So he's gonna do some triangulations to know how far the bulb is. But he is so smart, he automatically realized that triangulating the bulb from a flat lens would never work, because every time he does that, he gets different distances to the bulb. So he thought that the table cannot be flat, because if it was flat, then the elevation angles or light rays will intersect in the center of the bulb, exactly like in the first experiment. He has to think that the table is round, because the math will only work on a round table, because he had no idea what the atmosphere can do to the light. So this is what Eratosthenes did in details. Imagine this nail on the left side is Alexandria and the nail in the middle is Syene.
Sine in his experiments was 90 degrees below the sun, so that nail in our experiments is also 90 degrees below the bulb. Now the distance between Sine and Alexandria was 800 kilometers or 500 miles. But in our experiments, we can just assume it's 15 centimeters. We could have used 80 centimeters to scale it down, but we didn't have a bigger lens to cover that much distance. But it doesn't matter because the math of Eratosthenes works with all distances on the globe, and I'm gonna prove that to you too. Well, the shadow of this nail that represents Alexandria is 2.69 centimeters. So, to get the angle of deception that Eratosthenes used in his experiments, all we have to do is draw the nail that is 5 centimeters and draw the shadow that is 2.69 centimeters. And then we measure this angle and it is 28.26 degrees. So Eratosthenes divided 360 by his angle of deception, which was 7.2 degrees. But in our case, it's 28.26 degrees. So we get 12.73 centimeters.
So what he's doing right now, just as a quick explanation, Eratosthenes took the angle that he found from Alexandria and the distance between the two points, and basically figured that, okay, based on the angle and the distance, that's the circumference of the sphere that I'm on. Obviously, the numbers are different, but the relationships are the same, so he's plugging in the numbers that he received to prove to you that a light source going through a refractor, creating different angles, that the flat table that he's on can be mathematized into a ball. And the math works out fine, just like the way Eratosthenes did, but you're not actually on a ball, you're on a flat surface. That's the point of this.
Many decimals. Then Eratosthenes multiplied the results by the distance. If we want to do the same thing, then we should multiply 12.73 by 15 centimeters. So we get 191.08 centimeters in circumference. And that means that 191.08 centimeters is the circumference of the globe table. Now we can assume that the table is a globe because the angles work on it, right? So the table is now a globe with a circumference of 191.08 centimeters, which makes its radius to be 30.4113 centimeters. Okay, that's fantastic, but hey, get back here, we didn't finish yet. We are way better than Eratosthenes. We're gonna prove that the table is a globe by doing too many measurements and not just one. First, I'm going to measure the elevation angle of each nail. Here we go. This is the closest nail to the central nail, which is 5 centimeters away from it. Its angle of deception is 9.42 degrees, and its angle of elevation is 80.58 degrees.
So now you're going to see, so Eratosthenes just had like 2 points that he measured. What they did is they repeated the experiment with refraction and multiple points, whatever it was, like 7 or 8 nails on there. And he's going to show you that the angle of all of these nails matches the theoretical model that he created with math of a ball by ignoring refraction and making the surface curved. You're going to see that all the angles work out.
Same thing for the other nail in the opposite side. They got the same shadows. Now, if we want to do Eratosthenes' formula, then we will do this. 360 degrees divided by 9.42 degrees, we will get 38.21 and many decimals. 38.21 times the distance, which is 5 centimeters, we will also get 191.08 centimeters. The result is like the first circumference we got from a distance of 15 centimeters.
You see that the circumference comes out to exactly the same. So it confirms that this particular calculation was correct. It's the same that Eratosthenes did, except just with slightly different numbers, obviously.
If you remember. Now we will do the same thing with the last distance, which is 10 centimeters, and we should get the same circumference. Let's take a look at its angle of deception.
18.84 degrees. So again, 360 degrees divided by the angle of elevation, that is 18.84 degrees, we get 19.1 and many decimals. 19.1 times 10, we get 191.08 again. And the angle of elevation of this one is 71.16 degrees.
So all of them come out to the same circumference, meaning the math works perfectly.
Let's test these angles on a ball like we did on the globe model. Let's see if these angles really work. So I'm gonna draw our globe table with a radius of 30.4113 centimeters, circumference of 191.08 centimeters. Now I'm gonna draw the distance of 5, 10, and 15 centimeters on the globe table, because these are all the distances we used in the experiments with 9 objects. I was gonna use longer distances, but we only had a small concave lens that can't cover a bigger distance. So these are the distances. Now imagine the bulb rays are parallel just like the sun rays. The nails should be perpendicular on this globe, but we don't have to draw them because they are not necessary. So I'm gonna draw parallel light rays above these positions of these invisible nails that are on the globe now, not a flat surface. Now I'm gonna go ahead and draw tangent lines to be able to measure the angles. Now as everything is drawn, we can start measuring the angles and comparing them with the angles we got on the flat table. Let's start with the angles of elevation. First, we will calculate the angles of the 5 centimeter distance. The angle of elevation is 80.58 degrees. The angle of 10 centimeter distance is 71.16 degrees. The angle of 15 centimeters distance is 61.74 degrees.
So what he's doing, this is AutoCAD, it's engineering software that you can create sort of mathematical models. Now he's went from the other perspective. So before, what he did was basically do the angles, if I calculate the circumference of this theoretical ball, using these different shadows, do they all match? And they matched. They were all consistent with each other. Okay. Now he's going into AutoCAD and he created a ball with the particular circumference of whatever, 192.8 centimeters or something, and basically created parallel sun rays to measure the angles and to see, did the angles come out exactly as they were in the nails? Meaning, is there a match from the other direction too? And of course, there is a match because the math works out.
If we compare them to the angles we got on the flat table, we get the same exact angles. Does that mean that the table is a globe? No. The problem here is that we are not accounting for refraction. We are just doing the blind math that Eratosthenes did 2,000 years ago. So refraction made us think that the flat table is actually a globe because the math could only work on the globe. You want to measure the angle of deception of Eratosthenes? Let's go back to our drawing. Now watch. Here is the first angle that has to be 9.42 degrees. The second angle should be double, so it has to be 18.84 degrees. And the third one has to be triple, 28.26 degrees. You will get these angles everywhere on this globe. Does that mean that the table is a globe? The math here works perfectly. Eratosthenes' math was simple and genius, but it's all wrong because he never accounted for refraction, and now our scientists are making refraction meaningless so that math can still work. But no, sir, refraction is not meaningless at all, and we can prove that day after day. And again, I'm not saying that the atmosphere is concave like this lens. I'm just giving you an example of one type of refraction that worked on the globe and didn't work on the flat plane, even if reality is a flat plane. And this is why they don't work on a flat table or a flat earth. If you are here and got friends everywhere on the table, and all you have is the distance between all of you and the angles of elevation, then your lines of triangulation will meet somewhere on this line, way below the bulb, and that makes your triangulation incorrect.
See the problem? And again, we don't know the distance where the actual sun is, and what's its relationship to the firmament. Is it behind the firmament? Is it inside? We'll talk about this in a future episode, but we don't know this. This is the problem. We don't. That's why I don't make any claims about the sun. And I don't think you should too either. I make the claim that it's local to some degree, right? But I don't make the claim of its size or its distance or its position and so on. We don't know. You can't triangulate the sun. What you're seeing is an image, and the real sun, the source, who knows where exactly it is.
So you will end up saying that the table is a globe with a circumference of 191.08 centimeters, just like Eratosthenes. Well, smart people should already realize that the bulb we created by calculating angles from shadows has the same radius of the concave lens. Now, if the lens was bigger and the bulb is circling around it, and Eratosthenes is a small guy on the table, he will think that the table is a globe because the angles work on the globe. Here is something to think about. What if the sun circles above the concave lens? Or what if the concave lens is the one that circles below a fixed sun? What if this concave lens has the same radius of the Earth, 3959 miles?
In other words, the math that they got with the curvature of the Earth and the radius of the Earth and so on, what if that's actually describing the dimensions of the firmament? Do you get it? What if it's the firmament that they've calculated? Of course, they ignored the firmament, so it has to show up somewhere, and it shows up in the math of the globe.
If that's so, then I would have done the same math as Eratosthenes and told you that the Earth is 25,000 miles in circumference as well. Do we deserve a like and share?
Yeah, he's got some great videos. Like I said, eat the meat, spit out the bones, because I think he's still... I haven't seen any new stuff from him. I don't know if he was still working on some of these experiments or if, if he's taking a break or whatever. But he's got some good experiments. He does still believe, I think, the Earth is a circle, which, again, it just can't be. And the reason that's important, folks, is because the circle is so easy to refute. The circle is controlled opposition. It's there so that you can believe it and then be refuted easily and then made to look like an idiot. So if you want the truth, you have to, first off, come to terms with the fact that people will mock you and say, oh, how could you believe that? What? You don't even believe the Earth is a circle? What's wrong with you? What happens? How does continuity work? Well, it's supernatural. I don't know. And we're going to be exploring that. But the reality is that the Earth is not a ball. And you now have experimental proof that that's not the case. Eratosthenes only used 2 wells for his experiment. And, of course, he ignored refraction. And this experiment has been reproduced with multiple points to show you that refraction creates a situation where if you ignore refraction, you're going to transfer that refraction onto the surface that you're dealing with. In this case, he turned the table into a ball. And the math works out perfectly well. They didn't factor refraction, so it creates basically a mathematical illusion, is what it is. Now, Eratosthenes didn't factor in refraction because they didn't understand the behavior of light waves. People didn't really understand the ether, I don't think. The ether was discovered. And by the way, there's plenty of experiments we're going to go over in the future where there is proof that the heavens are moving, that the ether is the one that's moving, not the Earth. And those happened in the 1800s. And of course, that prompted the heliocentrists to prop up people like Einstein who said, oh, everything's relative. And of course, that just destroyed scientific inquiry, and people have been just gaslighted ever since. Relativity, we're going to debunk relativity and show you how impossible it is and how much nonsense it is. But of course, people believe it, and as a result, the globe has been able to hide behind relativity and relative motion. Anyway, but people have proven that the ether is the one that's moving. There's some sort of medium. Maybe the firmament is not just a barrier, but it's something more. Maybe it's the atmosphere too. I don't know. But he didn't understand the ether. He didn't understand the behavior of light. He didn't understand that light waves can't be parallel from a source. So far, We've never observed that. Light from a spherical source, light waves do not emanate in a parallel fashion. They can't. But of course, with math, you can sort of convince somebody that they can. Parallel light waves aren't possible, though. Experiments were never done to test for refraction. They were never done to falsify Eratosthenes, at least not until recently with this one that I'm aware of. Nobody's ever questioned refraction's impact on Eratosthenes' results. Eratosthenes does not repeat his experiment. There's nothing scientific about this experiment, folks. That's why you know it's a psyop. It's a story. And then you have people like Carl Sagan and Neil deGrasse Tyson going, ooh, and ah, and this happened and that happened. Oh, look at this and that. And they sweep you up in these narratives where really there's no science being discussed at all. NASA says that refraction isn't that significant, yet they use the argument of refraction against people who are trying to argue for a flat earth, for a cosmological, biblical cosmology. So which one is it? Is refraction significant or not? Obviously it's significant, and that can be measured. So that alone destroys the ball model. Experiments like this one, I don't know if there's any others, but I think he's done a few, have been done to prove empirically, physically and empirically, that you can take a flat surface with a light going through a refracting type of lens, and you can turn that surface into a ball, and the math works perfectly. That alone should tell you everything. And if that's the case, why hasn't this experiment by Eratosthenes ever been questioned? I'm sure they know the truth, it's just they don't want to admit it. If you ignore the firmament or the atmosphere, whatever's refracting the light, you're going to transfer the curvature onto the earth. It's inevitable. Again, 2 plus 2 is 4. 4 equals 2 plus 2. The equation has to be balanced. The relationship has to be maintained. Now, again, in math, those are two equivalent expressions. However, heliocentrism doesn't equal the flat earth. Okay, there's a cosmological difference there. You can't have simultaneously a curved earth and a flat earth at the same time. So one of them is true and one of them is not, meaning you can represent both mathematically, but one of them is actually the truth. Do you understand the important point? I hope you do. Eratosthenes projected his assumptions onto his findings, which is a great mistake in science. And nobody's ever questioned it, which of course is even more mistakes in science. He never repeated his experiments. He never did it with more data points. Nobody's ever falsified it. Nobody's ever asked about what independent variables there might be, i.e. refraction, the lens, the dome. Nobody's ever considered that. The globe simulations that people use never use refraction. When they show you all this CGI stuff happening and, oh, it works like this and the moon's doing that and the sun's rays are doing that, they never factor refraction in. And yet refraction is a very significant thing. They say that refraction makes the sun appear higher than it actually does. But again, if that's the case, then how can you possibly triangulate the position of the sun? How would you know? It calls into question everything that Eratosthenes did. And, very importantly, refraction actually has been demonstrated to work the other way around. The sun is not under the horizon. The apparent sun that you see is lower than the real sun, the source, or whatever the actual sun, whether it's a source or a projection, who knows what it actually is. But there's a relationship that's the opposite of what they tell you. The actual sun is higher than the apparent sun. So, point is, Eratosthenes' experiment was bad science. So what does this mean for you and me? Well, it means that you're being lied to when people cite this experiment. Pay attention to their language, how it's very assumptive, meaning it assumes all these things without ever questioning them. And, if you question it, you're stupid or whatever, you're ignorant. But the reality is that questioning this is the most scientific thing you can do, because this is bad science. You don't have to be a math nerd to understand everything we've covered today and what we're going to look at. We have a few more things to look at, very importantly, with angular size. You just have to understand science. Science is about questioning things. Science is about isolating independent variables from dependent variables, right? Eratosthenes did not isolate his results from dependent variables, i.e. refraction, meaning the result you get depends on the refraction. You get it? So the refraction is a dependent issue. And if you haven't ruled that out, and you know exactly what the lens is doing, then you're going to get an erroneous calculation, even though the math works out. At the very least, it means this whole situation with the shape of the Earth and cosmology and the solar angles and things like that, it demands further investigation, especially when the experiment has been completely falsified, as you can hopefully realize that by now. At the most, it's obvious proof that the Earth isn't a ball, folks. It really is. To me, it's obvious proof. Of course, there's other more significant proofs, but it's just proof. It's proof that the Earth is not a ball. It's proof that you can mathematize everything. Remember the first episode that we looked at all the horizon proofs. You cannot experience rising of the eye level, or rising of the horizon to the eye level on a ball. Doesn't matter how big the ball is. Because of the nature of the curvature, you cannot go upwards in altitude and see the horizon rising to meet your eye level. It doesn't happen on a ball. It can't happen. But it does happen, which means that the Earth is flat. There's a laser experiment, 41 kilometers over a lake that this guy Decimal Z did. You can check that out for yourself. It's about an hour-long video. Very cool video. Proof that there's no curvature. 41 kilometers is an enormous distance. And, there's no curvature. The LoRa test that we looked at, 800 miles. The 120 kilometer longest bridge in China. The longest observation, about 600 miles or 600 kilometers, I forget, but it's definitely a huge distance between Israel and Crete, I believe. We looked at the longest photograph, 454 kilometers. Earth is a flat, motionless plane, folks. The horizon is one of the easiest proofs in the fact that water's level. Heliocentrism is an inversion of the truth because it curves the Earth and makes the light rays parallel from the sun, whereas the Earth is straight and the heavens are curved in some form or fashion, which we saw last time. All the ancient cultures believe that. Square and a circle. How does it actually work? Who knows? But the point is that it's not a ball spinning in space. And the Earth isn't moving either. It's the heavens that are moving. And that's been proven too. We're going to look at Michelson-Morley, Airy's failure, Sagnak's experiments in the 1800s. All of these wonderful, simple experiments that proved the Earth is motionless and it's the ether or the skies that are moving. So there is evidence, folks, if you do your research, but that evidence has been suppressed. Videos like the ones that I showed you today aren't very popular because everything on Google or on YouTube is censored. In fact, even in my history, if I go to my YouTube history and I've watched any flat Earth videos, they're all censored. Like they're actually deleted from my history, which is crazy to me. I mean, it's just, if it's something that's just completely wrong, why censor it? Let people discuss. I don't understand why you need to censor it. That's how you know that there's something up. Now, we're going to talk about some math with, basically deceptive things that happen with math and angular size and so on. But here's the thing. People believe that math is an objective source of truth. And in some sense, it is objective, right? 1 + 1 is 2. But this is an important point to get today. I'm just going to keep drilling it home. It doesn't mean that when you make mathematical claims that you are describing reality. Very important. Math is objective. It's an objective frame of reference, right? So 1 + 1 is 2. Whether that you count rocks or sticks or apples or oranges, 1 + 1 is always 2. However, it doesn't mean that when you're making a claim using math, it's necessarily representing reality. Math is representing relationships. Remember the angular size problem. When you're looking at the moon, what do you see? Do you know how big the moon is from what you're looking at? No, you see how big it is in terms of the angular size in your visual field. That can be measured. But you can have all sorts of options as far as the size and the distance that's creating that effect. And of course, with refraction, some people have photographed the moon to be, huge, like how many, 10 times the angular size because of refraction. So this is the problem. You're dealing with a lot of uncontrolled variables. It's just like the Bible. The Bible is objectively true. It's the Word of God, but people use it for ill gain. And they twist Scripture to create lies about various things. And of course, people believe it because they know that God's Word is objectively true. And this is how the devil does his work. He uses the truth and twists it in order to create counterfeits. Heliocentrism and gravity are not true just because the math seems to work out. Do you understand? Math on the globe works out, but you've seen experimental proof now that math can turn a table into a globe and you wouldn't be the wiser because you ignored refraction. You can use math all you want. Until you have empirical evidence, you don't know the truth. That's why certain things are empirical, like the angular size that we see, which we're going to look at a few examples. And everything else is just conjecture. They say, oh, the angular size of the sun is 0.52. Okay, well, how far does the sun need to be to match the angles that we need, that we observe on Earth when the sun is passing overhead? Oh, I guess it needs to be, 900 gajillion miles away and this 900 million miles across. Okay, that makes sense. How do you know that? That's never been measured. That's just a theory based on an assumption, based on a conjecture. There's always going to be something missing in your assumptions when you're just theorizing with math. Until you test something and you have empirical evidence, it's not necessarily the truth. This is the point, folks. God gave us 5 senses for a reason, so that we would understand where we're at, that he's nearby and he's close. And of course, every ancient culture believed that for a reason, and they weren't stupid. Assumptions are not obvious in a particular model or a math model or a theory until you do experiments. Like this guy did with the table and the refractor. You can clearly see that the assumption that there's no refraction is wrong. And that becomes obvious when you test it with a reproduction of the experiment with a refractor. You can see very clearly that what Eratosthenes assumed was wrong. He assumed that there's no refraction. He assumed, therefore, that the Earth must be a ball. Well, that's not true. You don't prove the shape of the floor by measuring the ceiling, right? You don't go into like a place and you look at the ceiling and say, oh, well, I guess the floor must be the same way. I must be on a ball because the ceiling is a vaulted ceiling. No, that's nonsense. But yet this is the logic of heliocentrism. Now, it's the same with other things too, and this is what I want to kind of finish up with, is looking at a couple of examples of angular size and distance and how these things, with their own math, debunks them. The distance of the sun or moon can be whatever you want it to be. All you need to do is change the diameter of the sun. Does that make sense? The angular size is what you can measure. But to arrive at that size, you can say, well, the sun is, 1 billion miles across and quadrillion miles away. Or it's actually very close and very local and it's much smaller. Both of those mathematical expressions work, but one of them is the truth. Hopefully you are starting to see that. Math will always work out because math is about relationships. When you say that the angular size of the sun is 0.52 degrees, okay, that's measurable. It's like a quarter in your visual field. Okay, well, how do I get that quarter? Well, you can get it with, again, it's like you have, for example, 2 plus 2 is 4, right? You can also get 4 from other ways of calculating. 1 times 4 is 4, right? Or, a fourth times 16 is 4. All of those formulas are equivalent expressions. And in fact, maybe this is a better way to illustrate the problem with the flat model versus the heliocentric model. If I say 1/4 times 16 equals 4, that is equivalent to saying 2 plus 2 equals 4. Does that make sense? Those are two equivalent expressions in math. However, one of them is the truth. Either I have two things that are adding up 2 and 2 to make 4, or I have one thing that is really big, 16, multiplying it by something that's very small, 1/4, and I get 4. Do you understand? It's just a relationship. What you see is 0.52 degrees angular size of the sun. You can have 1,000,001 calculations that create that same result. You can have a very large sun that's very far away, or you can have a very small sun that's very local. They both work out. The question is, which one is the truth? And of course, the latter is the truth because we don't live on a ball spinning in space. It's like, for example, you can theorize that there's a unicorn through theories and create math measurements in simulations for the size of its horn and how big it must be based on the body of, let's say, a zebra or a rhino. And you can do all these calculations and calculate and have math and the diameter of the horn and how long the horn is and how much muscle mass this unicorn must have based on relative math models of zebras and unicorns. It doesn't mean the unicorn is real. Do you get it? You can have as much mathematized expressions of the unicorn. Doesn't make the unicorn real. You can say, oh, it's got this amount of light refracting the color of its hair, creating a purple hue, and it's got, pink spots on it because of this and that. It doesn't mean the unicorn is real. So now, fun fact, the Bible does describe, old translations do describe a unicorn, which of course was probably some sort of, pre-rhinoceros dinosaur type of thing. So that's interesting. I think that there were definitely rhinoceros type dinosaurs, triceratops, all these types of things. So that's interesting. But either way, you get the point. When I use the word unicorn, I mean like, rainbow-haired horse that's white with a giant horn. You could have all kinds of math to measure that. Doesn't mean it makes it real. We know that the sun is local, and that's all that matters. And that is very provable very easily. This is why also changing the sun for them in 2017 was so problematic, because it debunks the whole model. If you change the size of the sun, then the distance has to be much farther between the sun and the earth. You get it? Has to be different. And then therefore, your orbit around the sun changes, meaning your time completely changes and everything else. Everything falls through the floor. So here's some examples using their own math against them. We're going to look at angular size, and I'm just going to pull a couple of examples, and we're going to go increasingly more ridiculous with these. This is Tycho lunar. It's a lunar crater. Tycho is a prominent lunar impact crater. This is what they're telling you. Located in the southern lunar highlands, named after the Danish astronomer Tycho Brahe. It is estimated to be 108 million years old. To the south of Tycho is the crater Street, to east is Pictet, and to the northeast is Sassarides. The surface around Tycho is replete with craters of various sizes, yada, yada, yada. What's the diameter of the thing? It's 85 kilometers, or 53 miles, and a depth of 470. This is the math they're telling you. Okay, it's 85 kilometers. That's what you want to know. What's the diameter of this object in your visual field? So if we go to Google and we say, Google, what is the distance of the moon? Okay, well, the distance of the moon is 384,400 kilometers. Okay, 384,400 kilometers with a diameter of 85 kilometers. Okay, well, we can go to our angular. This is an angular size calculator. This is actually wrong because I put miles. You got to have the same units. So this is calculate angular diameter, right? So this is what it looks like. Here's U. Angular diameter is this right here, basically how much does it occupy in your visual field. And that's a function of the diameter of the actual object versus the distance. Now, this is a very interesting exercise because there's a limit to what the human eye can resolve, meaning there's an angular size that if it's below this angular size, 0.02 specifically, you cannot be able to see it. That is the minimum that you can see, like a speck that you can resolve in the visual field. So we take the units, which is kilometers, 85 kilometers in diameter, divided by the R, the distance of 384,400, supposedly the distance to the moon, and let's see what we get. Calculate. What do you get? 0.01. 85 kilometers diameter for Tycho. The crater. The crater is at the bottom of the moon. And actually, let me see if I can pull a picture up for you. Tycho crater. Images. You've seen it. It's this thing. See? It's this giant circle. And we'll talk about the moon as a projection of the Earth as a map in the future, which is a very fascinating thing if you've gotten into that. But this is the thing. You can see it, folks. Especially on a full moon, you can see it pretty well. It's pretty obvious. However, according to angular calculations, based on the diameter of this thing and how supposedly far, 384,000 kilometers. I mean, that's just insanity. It is below the minimum resolving power of the eye. You shouldn't be able to see it at all. So that's important. The next one is Jupiter. Let's find Jupiter here. Okay, so Jupiter, resolving power of the eye in degrees, we already know that, 0.2 degrees. So 0.2 degrees is the minimum resolving power, meaning when you measure these things, and you can do this on your own, Just take the diameters of these various objects they're telling you and the distances they're telling you and plug them into an angular size calculator and see what happens. If it's below 0.02 degrees, you are not able to see it. If it's 0.01 degrees, that means it's 100% lower or 50% lower than the minimum possible that your eye should be able to see. That's significant. Anyway, let's do another one. Let's look at Jupiter. Distance of Jupiter from the Earth. Okay. This one is, we're going to do it in miles. So it's 778 million miles, 300,000 million, whatever. 778, 300,000 miles away. Okay. So what's the diameter? Diameter of Jupiter in miles is 88,846. So we're doing it in miles this time. Okay, we're going to plug that into the calculator. This is 88,846. You can see here. So this is the diameter of Jupiter. The distance from you supposedly is 300,000 miles. 778,300,000 miles away. Okay, very, very large distance. If you calculate, it gives you the same thing, 0.01, meaning you shouldn't be able to see it, but you can see Jupiter in the night sky. In fact, if we do, let's say 3 decimal points, you see it's actually rounded up. You understand? Let's do 4 decimal points. 0.65, let's see 5, because this is all rounded up. Yeah, so you see, the actual angular size is 0.00654. Your minimum resolving power that you're able to see is 0.02. This is several factors below that. 0.00654 is much, much lower than the minimum resolving power of the eye. Yet you can see Jupiter in the sky. It's one of the luminaries that you can see. Probably the moon was that way too, because you have to set the decimal digits. Because for example, if you just set 1 digit, you see it's not going to give you the right answer. If you set 2 digits, it's going to say 0.01, which is still below the resolving power of the eye, but you need to get more specificity. 4 digits, 0.0065. That is significant. No way you could see Jupiter based on the distance they tell you and the diameter that they say. In order for you to see it, Jupiter would have to be, I don't know, let's see, double the size. Let's try 150,000 miles across in diameter. Let's try. You see, still not. Okay, let's try 300,000 miles in diameter. 300,000 miles. All right, let's see. Yeah, barely around 300,000 miles in diameter. Meaning, for you to see it, see this is 0.02. Now it's in the visual field. You understand? Jupiter, they tell you, is 80,000 miles, 85,000 miles in diameter, something like that. It would have to be, almost 4 times bigger than what they tell you it is in order for you to be able to see it, according to simple math. Simple math that we already know. And of course, again, they're going to argue well, what about refraction? It makes it see even though it's okay, well, let me posit that to you. Because again, people who use refraction, you're shooting yourself in the foot. According to simple mathematics, okay, Jupiter has to be 4 times the size in order for you to see it. Now, if you're saying that the reason I'm seeing Jupiter in the night sky is because the refraction of the atmosphere is making it appear 4 times larger than it actually is, do you understand the implication on the heliocentric model if that's the case? You can't have it both ways, folks. If you're going to argue refraction, and refraction is doing such significant things, but then when it comes to the position of the sun, no, it's not really that significant. The light rays are parallel, and refraction is not a big deal. Really? Which one is it? Well, obviously, globe math is very easy to debunk, but you got to know your math, and you don't have to be a math expert. But again, can you see Jupiter with the naked eye? Yes, Jupiter can be seen with the naked eye. No, it cannot. Well, it shouldn't be. Let me put it that way. It can be, but it shouldn't be based on their model of the universe. But of course, if you know the real model, then you realize that the luminaries are there locally and they have their purpose. Here's another good one. Tau Ceti. This one's the most ridiculous of them all. Tau Ceti is a single star in the constellation of Cetus that is spectrally similar to the Sun, although it has only about 78% of the Sun's mass. At a distance of just under 12 light years from the solar system is a relatively nearby star and the closest solitary G-class. The star appears stable with little stellar variation and is metal deficient, yada yada. It can be seen with the unaided eye with an apparent magnitude of 3.5. So you can see this star without binoculars, without a telescope, on a good night. You should be able to see Tau Ceti. Now, Tau Ceti is very interesting because of several things. First off, we know that it is about 78% of the mass of the sun, so we can say 79% of the diameter. Okay, and there's another thing here that I highlighted, I believe, somewhere. Yeah, luminosity. Luminosity of Tau Ceti is equal to 55% of the sun's luminosity. So they're telling you that this object is 12 light years away, which we're going to see how ridiculously far that is. Yet you can see it in the night sky, even though it is a quarter approximately a quarter less of the diameter of the sun and half of the sun's luminosity. Yet you can still see it in the sky. So we're going to put this claim to the test using their own math. Okay, how far is the sun from the earth? Okay, well, the average distance of the sun from the earth is 93 million miles, which is an astronomical unit. So the unit that describes the distance of the earth from the sun in the heliocentric model is called an astronomical unit, which is 93 million miles away. Now the question is, how many astronomical units is Tau Ceti? Let's find out. Well, 1 light year is 63,241 astronomical units. Okay, that means that we have to do 12 light years and find out how many. Now this gives you the exponent form, so we're going to go to the calculator. Actually, we'll go back. We'll go back to just 1. Make this simple. Okay, 63,241. That is the distance that a light year. So 1 light year, you're traveling 63,241 times the distance from the Earth to the sun. Okay, so we have an objective unit. Well, it's not true, but it's a unit. So now we're going to times 12 by 63,241 astronomical units. And we know that Tau Ceti, based on what they've told us, that it's 12 light years away, compared to the distance that the Earth is from the sun, it is 758,892 times farther away from us than the sun is from us. Does that make sense, what we did? 758,892. Did I note that down? Yeah, about 759,000 times farther than the sun is from the Earth, based on their own calculations. So now we're going to go to our angular size calculator, and we just put this in. The distance, you can check this for yourself. The diameter, I just plugged in 79% of the sun's diameter. So the sun is about 800 something thousand miles, whatever they gave you. I didn't document it here, but you can check this for yourself. 78% of that diameter is 685,610 miles across for Tau Ceti, supposedly, based on the math that they're giving us. Okay, we're going to put that diameter in there. We're going to plug in the distance that this is, which is, I don't even know what number this is, 7054000000000, however many zeros that is. It's a very large number, okay? We plug that in, and we see, based on the size of this object and the distance, would it be possible to see such an object in your visual field? And of course, if you go all the way to the maximum, it's probably even less than this, but they only go 6 decimal points, and you calculate it, this is what you get. Absolutely not. By factors of what, 1, 2, 3, 4, 10 to the 4th power less magnification, meaning your resolving power is 0.02. What this is coming up to, and I don't know if it would be even more based on if they had more decimal points available, but on the 6th decimal point, it tells you 0.000001 is the angular size of such an object, based on simply the diameter and the distance. Now you have to remember the fact that this object is also half the luminosity of the sun, meaning it has the half of the light energy that the sun is supposedly giving out. And of course, you also have to remember the inverse square law of light as it propagates forward, that light intensity drops off exponentially over distance. So you're telling me now based on just simple things that we know that we have empirically tested, inverse square law, the angular size calculations, that an object that is 25% less than the sun in diameter, half of its luminosity, and, cajillions of times farther away, you can see it in the night sky, and yet all the empirical evidence that we have, based on math, tells you that such an object would not be able to be seen. Not at all. Not even close. You would need who knows what kind of a telescope to see such an object, and yet you can see it. So this refutes their math, and it refutes their model, because again, you can type this into Google, and it says, can we see Tau Ceti with the naked eye? Yes, you can see Tau Ceti with the naked eye. According to the search results, Tau Ceti has an apparent magnitude of yada, yada, yada. How does this work? How? If you're going to chalk this up to refraction somehow, when, again, light, how does light even propagate through a vacuum? Light needs a medium. And we'll get to that with relativity, because that's what they did. They're very sneaky. They got rid of the ether. Einstein got rid of the ether and made space. And he made this wave-particle duality with the photon, which, of course, photons aren't particles. Light is a wave. And so anyway, that's another can of worms that we're going to get into. But the point is that they debunk themselves with their own math. And you can do this very simply. Just go to the angular size calculator and look it up for yourself. So, for example, if you were to convert these into more relatable numbers, because this is how they also get you, is with these numbers that are just so ridiculous, like, it's 5,000 quadrillion miles away. Oh, wow. I don't even have a concept for that. Of course you don't. That's nonsense. So if you were to convert these relationships, because remember, math is about relationships, what would you get? Well, for example, I did the math, and you can check this for yourself, with a dime and a nickel. Okay? A dime is 0.705 inches. A nickel is 0.835 inches. The relationship between the two is that the dime is about 84% of the size of the nickel. Now, Tau Ceti is 79% the size of the sun. So it's the dime relative to the nickel is a little bit bigger than Tau Ceti is to the sun, but that'll prove my point even more. So a dime is 84% the size of the sun, or the nickel. Okay, given these sizes, if you held a nickel a foot away from you in your visual field, which has about the same size as the sun, it depends. Obviously, there's refraction, there's different humidity levels and so on, but I'm not saying look at the sun, but if you kind of look at the sun, it's about the size of a nickel, let's say, depending about a foot away from your eye, give or take. Let's just use an approximation. Now, that distance of you holding a nickel a foot away from you is about 300 millimeters. We're going to use millimeters, so you realize how ridiculous this is. If now you took the dime, which represents Tau Ceti, how far would it have to be? Well, the answer is it would have to be about, what is this? What did I write down? 227,700,000 millimeters away to represent the distance that Tau Ceti is that they're telling you, 12 light years away. In other words, it would be 747,000 feet away, or in miles, about 141 miles. Now, I want you to just realize how ridiculous this is. According to them, the equivalent would be, like if you were to reproduce this empirically, put a nickel in front of you at a foot away, then take a dime, which is larger proportionally than Tau Ceti is to the sun. Take a dime and go 140 miles away from where you're at. And based on their particular math, they say, you can see Tau Ceti in the sky. It's impossible, folks. It's absolutely impossible. It's absolutely ridiculous. That dime would be disappearing in probably even before a mile away. Much sooner than that, let alone 140 miles away. That is how ridiculous this is. And yet you can see Tau Ceti. So the science tells you that you can see it with the naked eye, and yet the science is wrong about the distances and about the math model that it's plugged into. Real science is empirically observing what you're seeing and measuring it. We can measure the angular size of Tau Ceti. We can see it with your own eyes, that you can see it. Therefore, it is not going to be 12 light years away. But they have to create these ridiculous things because their model forces everything to be ridiculous. Just like with evolution. Everything is like 100,000 quadrillion years old. Really? That's not true at all. What assumptions are you making? And of course, the geological measurements are based on assumptions. and their assumptions are wrong, and therefore everything gets inflated. Everything is the opposite of the truth, folks. The truth is the earth is relatively young. It was created by God, who knows, 7,000 years ago, approximately. And, history is in the Bible. It tells you what history has been. Of course, the Bible is not a historical book, but it tells you from the creation all the way through the various empires and to the church age. It's not millions and billions of years old. That is insane. But they need it to be that way to make it seem plausible that things can evolve from nothing. Just like they need the sun to be a cajillion miles away to make it seem plausible that the rays are almost parallel to where you don't even notice, and so all the angles work out. Do you see how all this, it's just fakery, it's smoke and mirrors, it's impossible. Be honest with yourself and consider how ridiculous all this stuff is. None of these things have empirical evidence, nothing at all. In fact, the empirical evidence shows you that it doesn't align with the math model. If you didn't have that angular calculator and somebody's telling you, oh, what you're looking at is actually 14 million light years away. Wow, it must be so far away. Really? You're just accepting their story. It's not true. What you're looking at is an object. It's a luminary. But based on what we know empirically with the resolving power of the eye, which is measurable, empirical science, it is impossible for that object to be the size they're telling you it is and the distance they're telling you it is. It's nonsense. Same thing with the sun and the moon. You can see the angular size of the sun and the moon, but there are a million stories about how big that sun or moon is and where it is in space and what it's doing. There's 1,000,001 stories. And unless you evaluate those critically, it's very easy to be deceived. That's why it's not science. It's a spell. It's a magical spell. It's all just mind games with numbers and theories and conjectures and theories and assumptions. It's not actual empirical data, because every time you present empirical data, like the experiment with the table that we just saw, like the angular size calculations that we just did, and you can have fun and go and do it with all the planets and see, or in the various things that you can see, and you will see that there's a consistent theme, that the sizes are nonsense. Combine all this with charming storytellers like Eratosthenes and Newton and Neil deGrasse Tyson and Carl Sagan, and all these, oh my gosh, these stories, and this apple fell on Newton's head and he just discovered gravity. It's just fairy tales, folks. It's absolute fairy tales. What we see is explainable on a flat, motionless plane with a local light source through a refracting lens. As to how that entire system works, who knows? Who really knows? That's going to be the adventure of this series. And of course, my goal is not to solve that problem for you, but rather to reveal to you the mystery. Because it is a mystery, just like the Bible tells you. Well, I hope you've enjoyed today's episode. We'll see you next time. Take care and God bless.